Hi and welcome to this course. My name is Max and this course is about Ionic and React, two awesome technologies which we're going to combine in this course to build cross-platform applications. That means web apps and native mobile apps for Android and iOS. Now this course is packed with content and we'll dive into the different concepts step by step. No prior Ionic knowledge is required. You will learn it all in this course. You just need basic React knowledge. You should know what React is, and you should have heard about React hooks. If you don't know that, my React the Complete Guide course might be a great resource to take before this course.
So let's have a look at what will be in the course. In this first module, we're getting started. I will introduce you to Ionic, why we use it, give you a brief refresher on React, and let you know how Ionic and React work together. So this is a super important module to make sure that we all have the right foundation. Right thereafter, we'll dive into some Ionic basics. And with that, I really mean just Ionic. Because it turns out that Ionic also works standalone, and that's something we'll have a closer look at in this second module. But right after that, we'll of course also combine Ionic with React. You will learn how these two amazing libraries work together and how you can use these two technologies to build amazing applications. Thus far, we'll only have built web apps though. As you will see, by this point we only have a web app. But we're all here because we also want to build mobile apps. Well, no worries, I got a whole module dedicated to that. I will show you how you can turn your Ionic and React web app into a real native mobile app for both iOS and Android. So an app which really can be installed on real mobile devices. Now when you're writing code, sometimes things go wrong. So therefore we'll also have a module on debugging where you can learn how to find and fix errors. And even if your app is error-free, you of course want to make sure it looks good and it incorporates your corporate identity or a common theme. Ionic gives you rich tools for that, and we have a whole module in this course where we will dive in detail into the different styling and theming options Ionic gives you. Now, since our main goal is to build mobile apps with web technologies, we of course also have to find out how we can get native mobile navigation patterns into our app. I'm talking about things like tabs, a side drawer, or push and pop navigation. There is a whole module on that, of course, where you will learn how you can add those navigation patterns easily into your Ionic React app, and you will also see that they look good out of the box. Now, up to this point, we'll have learned a lot about Ionic and React. Therefore, that will be when we dive way deeper into Ionic, into its component library, and explore the many components it offers. You will see how you can use those components, where you can learn more about them, and how you can configure them. Of course, most apps don't just have nice components and a nice look and feel, but you also want to interact with your users. Now there will be a module where you learn how to handle user input, how to validate it, and how to manage your application state. This is also where you will really see which parts are controlled by React and which parts are controlled by Ionic. Now, as I mentioned before, we want to build real mobile apps, right? So of course, you will also learn in this course how you can use native device features like the device camera or the file system to store data. And best of all, you will not just learn how to do that on Android or iOS devices, but you will learn how you can easily set this up so that it works across all platforms, including the web. Yes, we will be able to use the device camera in a web browser. Now, of course, by that point, you will have learned a lot about Ionic and React. And it's super important that you don't just know which features exist, but that you also build apps that follow common patterns and practices and that are optimized. Which is why I added a whole module where we dive deeply into app optimizations and explore how we can optimize our code to make sure we're shipping the best possible application to our users. And speaking of shipping apps, of course, this course comes with a publishing module where you will learn how you can publish your app as a web app onto a server or as an Android app to the Google Play Store or as an iOS app to the Apple App Store. So loads of content included. And with that, let's start and let's dive into the most important question first. What exactly is Ionic and why do we use it?
So what is Ionic?
Ionic is two things actually. It's a web component library, and it's also the name of a company, the company behind that library. Now, to make sure we're all on the same page, I should probably clarify what web components are again. Web components are custom HTML elements in the end. So you can build your own HTML elements, and you can do that on your own with JavaScript. If you're interested, I got a course on that too, totally independent from this course, totally independent from Ionic. But you can use vanilla JavaScript to build these custom HTML elements, which you can then use in your page or on your page. And Ionic is just a collection of pre-built web components. Now, these web components Ionic offers you look gorgeous. They are absolutely stunning. They also look very professional, and their exact look changes depending on which platform your web application is being served for. So if you're visiting a web page, let's say on your Android phone, it would look very Android-ish, following the typical Android style. And if you would visit it on an iOS device, you would have a more iOS-ish look of that web app. So the look and feel automatically adjusts. And that's important, the look and feel, because we're not just talking about a different look, but also the animations behave differently and look differently. Now, with Ionic, with these Ionic web components, you can therefore build beautiful native device-like web apps. So we're still talking about web applications here, normal websites or the front end of normal websites, but with very little effort, with very little custom styling rules and HTML structure, you will get a great looking web application. You would still write all the logic you want to add with regular JavaScript, with or without any framework. Now, the cool thing is, Ionic as a company has not just worked on that web component library, but also released another technology, another tool, which is called capacitor. Now, capacitor works really, really well together with that Ionic web component library. Capacitor is a tool which allows you to turn any web app into a mobile or actually into a cross-platform app, which you can serve as a native app on iOS and Android, as a native desktop app, or also still as a web app. And I'm really talking about native apps here. iOS or Android apps created with help of that capacitor tool would really be distributed in the respective app stores. So I'm not talking about apps that look like native apps, I'm talking about real native apps. You can think of capacitor as a wrapper around your HTML, CSS, JavaScript web application, the front-end web application, which normally would run in a browser. And with that capacitor tool, with that wrapper, you actually produce real native apps, which you can upload to the respective app stores so that users can get them from there. And therefore, these two tools developed by the same company, Ionic, work together really well, because with both combined, you can build beautiful native device-like web apps, which you then convert into real cross-platform apps with capacitor. And that's Ionic. Now, a brief word about the history of Ionic. In previous versions, version 1 and 2 of Ionic, it was basically one tool that had these custom components, these custom elements, back then only for the Angular front-end framework, and it had the portability to build cross-platform apps also kind of built in. Since Ionic 4 we have a split, and since then we really have that web component library and that capacitor tool where both work independently, but where we get the most out of them by letting them work together. So we know what Ionic is and we heard about capacitor. Why would we use that? Well, if we only think about Ionic, the great benefit is that we get great looking apps with very little effort. We don't have to do much because we get all the styles, all the HTML structure out of the box, and we just have to compose a user interface with these web components we get by Ionic. So we can focus on our core business logic, which means the logic that really makes up our application, which we typically write in JavaScript, and we don't have to focus as much on the styling and the HTML structure. Now you can use Ionic standalone without capacitor. If all you want is a web app that looks good, you can use Ionic to achieve that. You can also use capacitor standalone without Ionic, and then you can wrap it around any JavaScript, HTML, CSS web app and turn that into a cross-platform app, which makes it easy to distribute that app to all major platforms without having to know anything about mobile development. And that's the big plus of capacitor. You don't have to learn Java and the Android framework. You don't have to learn Objective-C and Swift to build iOS apps. You don't have to learn C++ to build desktop apps. Instead, you take what you already know, you leverage your web development knowledge, and you build a web app which you then, with the help of capacitor, ship to the iOS App Store, to the Android Play Store, with the help of an installer as a desktop app, and of course, if you want, still as a web app hosted on some server. So whilst you can use each tool standalone, combined, you really have the best of both worlds and you can build native mobile apps with your existing web development knowledge. And you can do that really, really quickly, as you will also see in this course. Now, therefore, in this course, I focus on this combination. I will also dive into Ionic standalone, and capacitor standalone will be self-explanatory by the time we use it in this course. But you really are able to build the most amazing applications if you combine these technologies. And then using Ionic with capacitor is a great alternative to learning Java for Android and Swift and Objective-C for iOS development or anything like that. Because you don't have to do that, you take what you know and you build for all platforms. So we know that Ionic is great and capacitor is great and the combination is really amazing. Now, what about React? Because that's an Ionic React course. Why do we need React and all of that? Well, we don't need it. You don't need a front-end framework or library like React to build apps with Ionic and capacitor. They work totally independent of any framework. You don't need React, you don't need Angular or Vue or anything like that. You could build such a cross-platform app with just Ionic and capacitor and vanilla JavaScript, your own HTML structure, and your own CSS styles. But using one of these major frameworks makes writing real apps much easier. And with real apps, I mean realistic apps, bigger apps. And if you think about it, you don't need Angular or React or Vue to build normal web apps either. You could do that with just HTML, CSS, and JavaScript. We do use these major frameworks and libraries to make that easier for us as developers so that we can focus on the core logic that makes up our application, and we don't have to manage all the nitty-gritty details about showing or hiding elements, adding elements dynamically on the page, showing modals manually. We don't want to write all that code on our own as a developer. We want to focus on the real things that make up our application, on the complex things, on creating rich user interfaces and user experiences. And that's why we use libraries or frameworks like React or Angular or Vue in non-Ionic and non-capacitor apps as well. And for the same reasons we use these libraries there, we can add them to an Ionic capacitor app to build even more amazing applications with Ionic and capacitor and React or Angular or Vue in no time. And Ionic does really work with any front-end library or no library at all. As I mentioned, you don't need one. But you can therefore use it with React, Angular, Vue, whatever you want. And I do have an Ionic Angular course as well, in case you want to learn about that combination besides the combination we have in this course, which of course is Ionic with React. So long story short, we don't need React, but using it makes our life as a developer much easier for the same reasons why we use it in non-Ionic apps. And as you will see, the combination of Ionic, capacitor, and React is really, really amazing and makes it so fun to build awesome cross-platform apps. So now that we know all these building blocks, how do they work together? How does a typical Ionic project look like? So we're building an app, and when I say app, I really mean a cross-platform app. We're building a web app and an iOS app and an Android app, and we want to do that all with one code base and only with web development technologies. We don't want to do that with Java or Objective-C. We just want to use HTML, JavaScript, and CSS. So of course we can write that code on our own. We can write our own HTML, CSS, and JavaScript code, and we would have a fully functional web app. We could serve that on a web server, and we would be good to go. Now, when it comes to JavaScript, as I mentioned before, we want to make our life a little bit easier. We want to focus on the difficult parts, and that's why we would probably add a framework like React, or a library like React in this case, or a framework like Angular or Vue. Now, it's totally optional. You don't need that to build a web app, but often you will add it so that you can build more amazing web apps. Now, with that, we have a regular web app with HTML, CSS, JavaScript, and React. Now, of course, this is an Ionic course, and for all the reasons I mentioned, we want to add this Ionic component framework. And here, I'm really just talking about the web components, not about capacitor. We add that so that we have to write less HTML and CSS because we get more pre-styled widgets, you could say, more pre-styled HTML elements we can use to compose our user interface. Now, with this box, we would have everything we need to build an Ionic app, and we could serve this app as a web app or as a progressive web app. This is what PWA stands for. In case you don't know, a progressive web app is a web app which leverages certain native device features in the browser if possible, and if not possible, it will have fallbacks, which maybe also works offline. In general, you could say PWA is an enhanced web app. And if you want to learn more about that, good news! I got a course about this as well, where we dive deeply into progressive web apps. Now, I want to point out, though, that with this tech stack here, so with this box at the top of the slide here, we really build a normal web app. We could just turn it into a progressive web app. It would be very easy, but the key takeaway is we have a web app here. Now, of course, that's not enough. We want to build for iOS and Android as well, maybe also for the desktop. Well, that's where capacitor comes into play. We add capacitor into our project, this extra tool, which acts as a wrapper around our app. And with that, we can build for iOS, for Android, and we will get these app bundles, which we then upload to the respective app stores. And together with another tool called Electron, which is not the focus of this course, we can even build a desktop app if we wanted to. And this is the tech stack we would use in a typical Ionic React project, where we then use capacitor to serve our app to all these platforms. Now, as an extra tool, which I haven't mentioned before, we'll also use the Ionic CLI, the Ionic command line interface, which is a tool we use in the, command line of our operating system to create Ionic projects, to manage them, to run a development server. So basically, to interact with our project during development. It is basically a replacement for Create React App, you could say, or to be very precise, it's a wrapper around Create React App. So this is how an Ionic project looks like, and this is what we will build in this course ultimately. So we know why we need React, and we know why we might be interested in Ionic and this capacitor tool I mentioned. How does Ionic and capacitor, and I'll kind of use these words or terms interchangeably because they're from the same company. So how do these tools work behind the scenes, Ionic and capacitor? Well, when we create an Ionic project, an Ionic app, we write some code in React, for example, but as I mentioned, you don't need a JavaScript framework technically. So we write our JavaScript code with whichever framework we want, and we probably, since this is an Ionic course, throw in some Ionic web components to have these beautiful components which automatically adapt to the underlying platform to have the Android or iOS look and all these beautiful animations. So we have this app. Now you learned that you can use capacitor then to turn this into a native mobile app, because the box on the top, that's basically a web app, right? It's a regular web front end with React and Ionic, so only web technologies there. And then it's capacitor, which turns it into a native mobile app. But The question is, how does Capacitor turn it into a native mobile app? Does it take our web app code, so HTML, JavaScript, and CSS, and compile this to a native code? So does it translate our existing code to the Java and Objective-C equivalents for the Android and the iOS platform? Or does it compile it to machine code which runs on mobile devices? Or does it use another approach you could think of, where it takes your web app and wraps this into a mobile app? What does it do? Well, it does the second thing. It takes this web app and wraps it into a native mobile app, into a real native mobile app. Now, what's that? What's this wrapped web app thing? How does this work? Well, in the end, once we're done with everything, once we are done working on our project with Ionic and Capacitor, we want to have a mobile app which we can distribute through the app stores, so which ultimately can be installed on different devices, right? So we want a real mobile app which you can download and install from app stores. That's our goal, and that's what we can get with Capacitor. Now, Capacitor works such that it essentially gives you automatically behind the scenes a very simple mobile app which acts as a wrapper for your web app. And it does so by in the end hosting your web app inside a so-called web view. Now, a web view is just a technology which is supported by both iOS and Android, which is basically a screen in a mobile app which takes the full screen, which hides all other displays you might have in there, and which hosts your web app, which you build with React and HTML and CSS and JavaScript and Ionic, so which takes this web app and hosts it on a local mini server that runs inside of the web app, you could say, so that to the end user, it is like a totally normal native mobile app. You won't be able to tell a difference. You, as a developer, therefore, are able to distribute it through the app stores, and it can be installed as a native mobile app. This mobile app also, thanks to Capacitor, which acts as a bridge between your hosted web app and the underlying operating system, has full access to native device features like the device camera. So Capacitor does all the wire up work to make sure that your Ionic React app has unlimited access to everything a normal mobile app would have. And you really should put that into quotes because you have a regular mobile app in the end here. And of course, you have one thing though. You have a slightly worse performance than in real native apps, which you create by writing native app code. So which you create by writing Java Android code for Android and Objective-C or Swift code for iOS. But I know that this sounds very intimidating. Let me tell you from experience that you won't feel that performance anywhere in 99% of all apps. There might be niche cases, very performance-intensive apps, where you might feel a difference, but chances are that those apps actually are not really programmed in the best possible way and could also have better performance if they were done right. And of course, you'll learn the right way to do it right in this course. There are many apps out there in the app stores, maybe already running on your device, which use Ionic and Capacitor, and where you won't be able to tell a difference. So don't get intimidated by this. This really is an amazing approach of letting you leverage your existing web dev knowledge and get a real mobile app in the end. And this is how it works behind the scenes. It's not really so important for you as a developer. It won't influence how you write your code. I just find it interesting to understand how that works behind the scenes. But with that, let's move on. So we know how Ionic works behind the scenes, and of course that might bring up one valid question. Which alternatives do we have to Ionic? And again, I'm using the term Ionic here kind of as a summary term that also includes Capacitor. Now with Ionic and Capacitor, we can build those wrapped web apps, as I mentioned. So as I mentioned multiple times now, you utilize your existing knowledge and you get a real web app out of that. Now, of course, one alternative, which I won't even show here because it's so obvious, is that you build a real native app by learning Java and the Android framework for Android and Objective-C or Swift as programming languages for iOS. The obvious disadvantage of doing that is that you have to learn 2 brand new programming languages and respective frameworks, and you won't really be able to use this knowledge anywhere else than for mobile app development. So you have a lot of work to do to build apps there. As another disadvantage, even if you learn all those languages, you have to build 2 apps from scratch. You won't be able to reuse any Android code in your iOS app or the other way around. On the other hand, with Ionic, you use your existing knowledge. You only need to learn 1 programming language, JavaScript and the React framework, of course, and you then write the app once, and you automatically get an Android and iOS app, which even looks good on the respective platform thanks to Ionic, without any extra work. So that's the huge advantage there. But which alternatives do we have? Maybe we have other tools which also allow us to reuse our existing knowledge and write code only once. And we do. There also is React Native, which also allows you to write native apps with React. Unlike Ionic, it does not use this wrapped web app approach. Instead, it in the end compiles your views, so the markup language for what's visible on the screen, and your JavaScript code is hosted in a mini server, you could say, that's also running side by side to those compiled views. So it's not entirely wrapped, it has this compilation step, which might sound more attractive because of performance reasons, but as I mentioned, you won't really feel that performance disadvantage, and I'm serious about that. And in addition, you also have to learn a new styling syntax for using React Native. It does not use native CSS. You don't use HTML there, you use an HTML-ish language, or you could say, and in general, it's a little bit more work. Nonetheless, it is a decent alternative, and if you're interested, I do have a full course on that as well, which you can, of course, take. And then we have another great alternative, and that would be Flutter. Flutter is not following an approach where you use web development knowledge. It actually uses a brand new language, Dart, which is developed by Google. Flutter is a framework for Dart, which is also developed by Google. And it also, however, then uses this Dart language and a lot of features which are built into Flutter, a lot of components which look gorgeous, and then you also only write code once and you get an iOS and an Android app out of that. This also is then compiled. Dart, the entire app, is compiled to machine code, and therefore you can get that extra performance if you really need it somewhere. You have a lot of built-in components which look beautiful, and it really is a decent alternative, but of course you have to learn that brand new language and framework. So it is more work than, again, using what you already know. I also do have a Flutter course, however, if that sounds interesting to you and you also want to learn that. That being said, all 3 alternatives here are great. They each have their advantages and disadvantages. This, of course, is an Ionic React course. It is an amazing choice because you will see throughout the course how fun and easy it is to build mobile apps with it. And therefore, let's continue with this. Now, I know, I have been talking a lot. We should get started now, and we will soon, no worries. But I briefly want to walk you through the Ionic history because it is important to understand it, to understand which version this course covers and which version you should learn. Ionic is a company, as I mentioned, and they released this Ionic framework and this entire tool set that allows you to create mobile apps, and they did so in 2013 with Ionic 1. Now, back then, this was a framework which only supported Angular 1, also known as Angular.js, so one JavaScript framework, and it also didn't bring its own converted to mobile solution, so it didn't include capacitor. Instead, it was based on another open source alternative named Cordova, and it could be a bit clunky, but generally it worked fine. In 2016, we got Ionic 2, which was based on the brand new framework Angular 2, which was totally different than Angular 1. And in 2017, we saw Ionic 3, which was basically an enhancement of Ionic 2, which also included better support for not just mobile apps, but also for progressive web apps. So for the first time, we had a real cross-platform solution where we could build more than just mobile apps, you could say. Now that's the past. Then we had a huge, very important new version in 2019, and that was Ionic 4. Ionic and 4 changed everything. The Ionic team moved away from Angular. They now supported every framework, or no framework at all if you wanted that, with vanilla JavaScript, because now Ionic was really just a web component framework. Prior to Ionic 4, it was an Angular component framework. All those components were built with Angular. Now they were built with native web standards, so with the web component specification, with vanilla JavaScript, and therefore this was the first time Ionic components worked with every framework. This was also when they released Capacitor, their own alternative to Cordova, which, because they now had full control over it, really fitted into this whole ecosystem in a nicer way, and which in my personal experience is much nicer to use than Cordova. That being said, Capacitor is and was fully backward compatible to also support existing Cordova plugins. But in this course, we'll focus entirely on Capacitor because it really is the future of this cross-platform mobile app development with Ionic. Now, since then, they released new versions, and we got new versions coming out all the time, but unlike in the past, every new version does not mean that everything changes. Instead, we now have gradual enhancements, smaller improvements, and of course, I will keep this course updated to include these smaller changes, because now not everything changes, but only, as I said, small things. That's the history. You are learning the latest version of Ionic with this course, and it is the latest version which you should of course use to build cross-platform apps with Ionic Capacitor, and in this case, React. So now, finally, let's get started, and for that, let me show you how you can get the most out of this course. Now, of course, it's a video-on-demand course, so watch those videos at your pace. You can slow me down or speed me up in this video player if I go too fast for you. Now, of course, this course has some prerequisites. You should know basic React, so if you don't know that, definitely learn it first. Otherwise, following along will be very hard. But then, to really fine-tune everything to your requirements, follow along at your pace. I also recommend that you code along. We will write a lot of code in this course. There will be chances for you to practice what you learn, and you really do learn the most if you just, code along and build your own app along with me. You'll find code snapshots attached to the last lecture of every module, so that if you get some error or you can't reproduce what I had in the video, so that you can use those snapshots and compare your code to mine, or temporarily replace your code with mine to find out what went wrong. So take advantage of that. Now, of course, also, if you're facing any errors or you're having any problems, you should debug your code on your own. Use the normal web development debugging tools like the Chrome developer tools. And also, if you're getting errors, read those error messages, use Google and try to fix them on your own. Now, of course, I will also provide some support. I'll come back to that in a second, but this really is how you learn the most. So I would encourage you that you really do that if something goes wrong. Now, if you absolutely can't find a reason for a different behavior or for an error, you can, of course, ask in the community, that Discord community, which was linked, and also in the Q&A section of this course, where I will do my best to provide fast and friendly support for course-related questions. I can't help on personal projects, though. But also, don't just post there and read there, but also try to help others, because ultimately, this is how you learn the most. If you help others, you can learn way more because you're challenged to think about a problem and find a solution. And this is how you ultimately get the most out of this course. So finally, let's get started with Ionic, and let's actually really get started with Ionic. So I mean with just Ionic. Because it's important that you understand what Ionic is and how this Ionic thing really works, what web components are and how you use them, so that you then in the next step can combine that knowledge with React. I find that important because you probably already know React. You will learn how to combine it with Ionic, but we have to cover Ionic first. So in this module, we'll have a look at how we can work with Ionic without React. So how we can really just use that, because I mentioned that React is not mandatory. No JavaScript framework is mandatory. You could use Ionic with just vanilla JavaScript. And we will then also see why we still might want to add React though, even though we technically don't need it. Now, when I talk about Ionic, for one, I of course also always meant Ionic and capacitor, so these two important technologies, you could say, that are managed by the Ionic company. But I also of course mean all the different things that make up Ionic and Ionic apps and Ionic projects you'll be working on. And the most important thing there, of course, will be the user interface components you'll be working with. These are two examples which actually exist, and you will see them all throughout this course, and I will show you where you can find them all. But these are essentially HTML elements. But of course not HTML elements which are built into the browser like this, which the browser understands like this, but instead added and unlocked by Ionic, by adding an Ionic script import into your page, and then by some JavaScript code which gets executed there to basically define these elements to the browser, so that the browser knows what to render when it sees these tags. That's the idea behind web components, and that's what Ionic utilizes. It's a web component framework. However, Ionic projects typically consist of more than just HTML pages with these special elements. For example, Ionic projects, as we will work on them throughout the course, will also make theming and styling easy. They embrace vanilla CSS. They heavily utilize a built-in CSS feature, which is called CSS variables, and also many other things. And you will see all of that throughout the course as well. One thing you can already memorize is that you will typically use vanilla CSS. You could also use Sass and so on if you preferred that, but you can write beautiful apps with built-in theming. So where you, for example, set a color only once and then use it everywhere with just CSS. And as a side note, if you want to learn more about CSS and CSS variables, you can also have a look at the CSS course I created together with Manual. Now, one other important concept which is incorporated into Ionic and which will also be supported out of the box in Ionic React apps later is navigation. In mobile apps, you will see that we have some typical navigation patterns like using tabs or a side drawer, and Ionic will make it very easy to use such navigation patterns and to, for example, add tabs to your application. One other important concept which we need for building modern user interfaces is state management. We need to be able to pass data around and to ensure that when we do something in one place of the app, let's say when a button is clicked, something happens somewhere else. And this is also something which is kind of built into Ionic. It gives us some tools that help us there, but I can already spoiler this a bit. This is also one thing where React will help us, and one of the reasons why we might want React. Now, when we also expand the term Ionic a bit and we include capacitor in the equation, then we can also tap into native device features, and that is something which is of course super important. With the help of this capacitor technology, which is developed by the Ionic team and which therefore integrates perfectly into Ionic apps, we can use the device camera, get the user location, write something to the device storage, and much, much more. And these are all things we'll also do in this course. You will learn how to use the device camera, take photos, and store them. That's all included. And last but not least, when we talk about Ionic, there also is one other crucial tool that has to be included. And that is the Ionic CLI, but also all the different features Ionic gives us to manage our projects. The Ionic CLI CLI stands for command line interface, will make it easy for us to create projects, to test them, and also then to pack everything up, to optimize everything for publishing, so that you really can easily take your Ionic app and put it onto a real app store in the most optimized version possible. These are all the things. As I mentioned, state management, that's where React will be important. Native device features, that's where a capacitor will be important. And for now in this module, we will actually focus on the UI components so that you get a feeling for that and see how that works. And then throughout the course, once we also combine Ionic with React and we create a project with the Ionic CLI, we will step by step introduce all these different features so that by the end of the course, you're able to build real native mobile apps or actually cross-platform apps with Ionic and React. So we get those Ionic components, as I mentioned, these HTML elements which are unlocked by Ionic, and we will start using them in just a second. They will look like this. This, for example, is a component that we can use once we included the Ionic script into our web app, into our website, into our HTML page. It's named Ion button, and that's of course an HTML tag, which is not supported by default. If you would put this into a HTML document like this, it would not do anything. It also wouldn't throw an error because HTML is actually a language which is quite forgiving, or to be precise, browsers are quite forgiving. You can use unknown HTML elements and the rest of your page will still render fine. But for this element to bring something onto the screen, which we can see and with which we can interact and which really has everything this button should have here, for that we will need Ionic in this case. So we will have these HTML elements, which we use like normal HTML elements. They also, as you will see throughout this course, can have attributes and properties which we can target either via JavaScript, or when we add it in markup like this, we can just add attributes like we always do on HTML elements. And they will also be able to emit events. So for example, on this button, we'll be able to listen to a click. Well, enough of the talking. Why don't we just get started and do this then? To get started, let's visit ionicframework.com, and there you can learn more about Ionic. Always a place worth visiting. I can also recommend their blog to learn about the latest developments of Ionic. But for now, let's just click on Platform here, and then Ionic Framework. I basically want to get to those docs here. Now, these docs here are pretty good. You can learn a lot about Ionic here. I absolutely can recommend checking them out, but of course, I will kind of replace these docs with this course for you. I will show you all the things that matter, but these docs are always great to also have a written guide, or maybe dive deeper into some components or some concepts which we only use a bit maybe. So in here, we can get started by going to installation and then here, packages and CDN. Now, we will soon use the CLI, no worries, which is this tool that allows us to create local projects. But for a very simple project, we can just use a CDN. So basically, we can import an Ionic JavaScript package which lies on some server, which we can just include. So if we click here, we see these three HTML elements. Copy them, and now create a new HTML file anywhere on your system, in any folder of your choice. Here, I created a file named index.html in a folder named Ionic React, and you can store this anywhere you want. And I opened this in Visual Studio Code. Visual Studio Code is a free coding IDE, which is great for web development. You can get it for free from code.visualstudio.com. It is available for all operating systems. And you can simply download it from there and install it and then open your code with it. And I just like it. I use the dark plus theme here in case you're wondering why it looks the way it looks for me. Here, dark plus. And I also installed two extensions, which I would recommend that you also install. The first one is the material icon extension. It's optional, but it changes the file icons to look the way they look in my course here. So if you like that look, you can go for that extension here. And I also got another extension installed, and that is prettier, and that will help us with automatic code formatting. So that if I press a specific shortcut, which you can find under Preferences, Keyboard Shortcuts, and then if you search for Format Document, this shortcut, if I press this, the code will automatically be formatted to be prettier and easier to read. These are 2 extensions I would recommend that you use. Of course, you can install more. I do expect that you already have a development setup, since React knowledge is recommended and expected for this course. So I will not dive too deeply into that, but that's the setup I'm using. Now with that, I got this HTML file. It's an empty file right now. And in Visual Studio Code, I can just type HTML and then choose that second option and hit enter, and we get a basic HTML skeleton. Now here under title, we can insert these free HTML tags we grabbed from the Ionic website. And you can also change the document title here, of course, a bit if you want. I'll name it Ionic Basics. Now with this, we have a very simple HTML document, which has no body, which is empty right now. And we can just open that. For that, I'll open it in Finder, and then double click on it to open it up in the browser. Here it is. So this is this page running in the browser. I can open up the developer tools to see if we got any errors. Right now we don't, because also there isn't much on the page, of course. But we will soon change this. Now we got that on the page, and now let's add a new HTML element, but one which is not built into HTML, which is not regular HTML. The Ion button. Just add this like this, an opening and closing tag, and in between I'll add click me. Now of course, normally this wouldn't work. If you temporarily cut those free imports we added and save this file and reload, you see just click me here, but yeah, nothing happens. It doesn't look special. If we inspect it, we can see that the browser detected this element, but it didn't know what to do with it. Well, that changes if we bring back those free imports and we save this again. Now, if we go back and reload this page, oh look, this looks more like a button. We can tap it, and of course nothing happens right now if we tap it, but you can already see that without us writing any JavaScript or HTML, this seems to be more than an undetected HTML element. And indeed here in the DevTools, you can also see there is this strange shadow root thing, and yeah, in there we got stuff. So something happened here. And if we open the console, we of course also get no error. So this is now a button. And now we can interact with this button here. We can add our own script, let's say here at the bottom, little inline script here in HTML. And we can select this button and store it in a constant with document query selector and select it by its tag. This is possible. Ion button like this. And of course, this is not React code. This is vanilla JavaScript. We will switch to React soon. No worries. And we can now add an event listener here to the button if we want to. A click listener, for example. And register a function. Here I'm writing an arrow function, which will fire whenever this is clicked, hopefully. So we can console log clicked here to see whether that works. Now if we save this and we go back and I reload and I click this, we see clicked here on the right in the console window of my DevTools. So this is working. And why is this interesting? Because it normally would not work. It isn't a normal HTML element. The look we have here and all the features which are built in, of which we're currently only scratching the surface, this only works because of Ionic. And this is a so-called web component. It's a custom HTML element. You can build those on your own as well. And I got a course on that too if you're interested. But here the Ionic team built a couple of components for us. We can just drop them into a page and use them. And of course, there's more than just a button. If you go back to those docs here and you actually go to components here at the top, you see there are a couple of groups of components, and you can click, for example, on the button. And now here you got a detailed description of the button, and there are way more components built in, as you can tell here. If I zoom out a bit here and reload, I also get the side menu. Here it is. And now you see there are a bunch of components built into Ionic which you can use. And the official docs are nice because you always have this preview on the right to see how this component looks and works. And you see detailed descriptions of how to use it for different frameworks or vanilla JavaScript, and how to configure it, which properties you can set, which attributes you can set, and so on. So these docs are awesome, and I will come back to them from time to time, but for now, we added our first button, and that's pretty amazing. So we got this button here, this standalone Ionic element, and we connected a click listener. That's nice. Now, let's add more, because we got so many components here. Let's add more components, and let's start building a very simple first application, where we then can later also understand why we might want React in the equation. I want to build a simple body mass calculator where we can basically calculate, well, our body mass index. Now, in case you don't know, this is the formula. We can calculate the body mass index by dividing weight in kilograms by height squared in meters. Or if you're not using the metric system, I can tell you 1 kilogram is 2.2 pounds and 1 meter is 3.28 feet. So that's how we will be able to convert our different measures. Now, that being said, that's the formula. That's what I want to build here now. Now, thus far, we just have a button. Not really what we need, right? Now, we certainly need 2 inputs to let the user enter a weight and a height. And to keep things simple, I'll start with the metric system. We will adjust this to also allow for other inputs, but for now, let's start with the metric system. You saw how you can convert values on the slide before. And yeah, with that, let's build it. So we need an input. And if we scroll through the list of components, we do see an ion input here. This is an input element which we can add, which can be styled and configured in different ways, as you can tell. And that looks just like what we need here. So let's go back to our page here. Let's actually remove the button and the script. And let's add an ion input, opening and closing tag. Now on this ion input, we can configure various things. And if we switch this here to just JavaScript, we also see that we can combine it with an ion label inside of an ion item to basically give this input a label. So maybe let's do this, because we can then also configure the label to, for example, be floating above the input when we click into it. So let's add an ion item, which seems to be another component provided by Ionic, and add an ion label. And here I will add your height as a label. And now I'll duplicate this to have another ion item where I ask for the weight. And then I have another input. Now on both labels, I will add position equals floating. How do I know that I can add this? Well, because of the official docs, which I really recommend that you dive in from time to time, because there you can see all possible configurations and what you can do. So here we get the floating position. We could also set it to fixed, and you can see the different positions partly here in the preview, and of course you can also just give it a try. So here I added position floating, and I'll do the same here on the weight. If you save this, and we go back to our little application and we reload, we see these 2 inputs, and we can click into them, and they float. And now here's also something very nice. In the Chrome DevTools, and I would recommend that you use Chrome to follow along, you can click on this icon here. This will give you a preview of the web app as it will look like on a mobile phone in the browser. So this is not a preview of the mobile app, but of course it's really close. This is how it would look like on a mobile device, and therefore most likely also how it would look like once you build it for a mobile phone. So here is how it would look like on a mobile device, most likely. Now that's nice, that's a good start. We got our 2 inputs here, but we're not really done. There are more components, but of course I don't just want to go through the docs together with you, so we'll show you another very important component here. There is an ion content component, and you always have just one ion content component per page, so per HTML document in this case, and you should put your content into that. If you do that, and here I just pressed the prettier shortcut to format this, and you reload, you will not really see a difference. This is just a good practice. It's especially important if you then combine it with another component Ionic ships with, and that's the Ion header. You add this above your content, and there you add a Ion toolbar typically, in which you add a Ion title. There you can now set a title which will be displayed on the screen, for example, BMI calculator. This then all should be wrapped in an Ion app, and you only have one Ion app element per page as well. So you can probably see a theme here. You have a header, which you will see in a second is something that is on the top of the page, and then you have the main content. You could also add a footer, but here we don't need one. Now if we save that and we go back, this looks good. Now we get this header here, and we can configure this a bit more. We can go back, and on this toolbar, we can add a color. We can set this to primary. Now, primary is one of the supported colors. I will dive deeper into theming and styling in a separate module. For now, let's just add primary here like this. And now if I reload this, hey, now it has a blue background. And this now really looks more appish already. So we added these inputs with their floating labels, we added this toolbar, and we did all of that with all those nice stylings and effects by just adding a couple of HTML elements, which are not really HTML elements, but which are custom elements unlocked by Ionic, by this Ionic framework we added. That's, of course, pretty nice. So that's the first step. Now with that, let's continue, and let's make sure that we actually turn this into a real BMI calculator, where we really calculate the, body mass index of an individual. So we get started with this body mass index, and more importantly, with our first Ionic app, therefore, with just Ionic, no React involved thus far. Now my goal is to add a button, and when we click this button, I want to output the body mass index of the user below the button here. So let's add something new below our two items here, and that's the Ion button, which we already saw before, and there we could have a label of calculate. And when we click this button, I want to calculate that body mass index, and I want to output it below this button. Maybe here in a div, and that's important. This, of course, is now a regular HTML div, because just because you're using those Ionic elements, those Ionic components, does not mean that you can't use regular HTML elements anymore. You absolutely can, and it is quite normal that you do. So really don't get confused by this, you can do this. And here I'm adding a div with an ID of result, because I want to be able to select that div with JavaScript to then add and output the result inside of the div once we got it after we clicked this button. I will also give these inputs IDs so that we can easily select them via JavaScript and read their values. So here we got the height input, let's say, and there we have the weight input. Now with all of that, it's time to add some script code, and therefore I'll add an app.js file. The name is totally up to you. This is just a JavaScript file, which I now will import here, and I'll do that, let's say here, by adding a script. Source is app.js, and I will add the defer attribute here to make sure this only starts executing after the entire HTML file has been parsed. In case you didn't know defer before, my complete JavaScript guide is the place to learn this and all about JavaScript. So here I added this import. Now we can select the button to add a click listener, select the two inputs to get their values, and then of course ultimately calculate a result once we got these input values to then output it down there. Let's do that next. So in order to get started with all of that, let's go to app.js and let's select a couple of things there. The calculate button, for example, by using document query selector, and then we can just select the first Ion button we find, because we happen to only have one Ion button in here, so this is the button I'm interested in. If we had multiple buttons, we could of course add an ID to this button to select it by that ID. That's, by the way, something we'll do for the two inputs here. We have our height input. We can get this with document get element by ID, and then it's height input. This is the ID, which we added to this input. And of course, for the second input, we can simply repeat this here and just select it by that different ID. Now we can add a little listener here to the calculate button. Click listener. And after clicking this, I want to execute a function which I'll store in a new, function. You can write it with the function keyword or create an arrow function which you store in a constant, which is what I will do here. I will name it calculate BMI, and that's just an arrow function, and that's the function I'll hook up to this click listener. So that's really just regular JavaScript. Now in here, I want to get the values which were entered into these two inputs. So we got the, let's say, entered height by selecting the height input, and there's simply the value property, like this. And we do the same for the entered weight by selecting the weight input here. Weight input. Whoops, I should rename this up there too. Now here we know that we will definitely find elements with these IDs, and they will be input elements. If you didn't know that with certainty, you might add a if check to check if height input or weight input would be null, but here we know they won't be because we have these elements on the page. Now we can get our BMI by making this calculation. We want to work with numbers though, and as you know, what you select with the value property will always be a string, so I will add a plus in front of that to convert the string to a number. Again, we could of course check if that failed, if we maybe got not a number as a result, and technically that could happen in this application if the user entered anything but a number here, but I will assume that we just enter valid data here. Of course, you can add a if check for some validation. For simplicity, I will omit it here. And now the formula was weight divided by height squared. So entered height times entered height here in brackets, so that this gets calculated first, and then the result is taken to divide entered weight by it. And then for now, I will just console log that BMI to check whether it works. We will soon output it on the page, but for now, let's just do this. Back here, let's reload. And now I will enter my height here in meters. That's important. So if you're not used to the metric system, simply use Google to convert your height and weight to the metric system, so to meters and kilograms. And here I'm 178 tall, and my weight is 72. And let's press calculate here, and that doesn't look right. Simply, because that should be the entered height here, not weight. Had a little bug. Let's reload. 1.78, 72, and that looks way better. That's my body mass index, which is absolutely okay. So with that, we got this finished, but of course this app has a lot of flaws. We can't enter anything here, and that will just lead to not a number being output. We also don't output the result anywhere on the screen, just in the console, which is not optimal. And of course, styling also is maybe not where we want to have it. And of course, also in addition, this only works with the metric system. We currently have no way of switching to, let's say, pounds and feet or anything like that. So these are things where we can improve this. Before we do that, however, let's have a look behind the scenes, all these Ionic components, because now we work with some of them, which is nice. How do they actually work under the hood, though? So we played around with some Ionic elements. We can work with them from inside JavaScript, that's great. But how do they actually work internally? Is this magic? How do these web components work? Let's take that good old iron button with which we worked before. As I said, this is a web component unlocked by Ionic, by this Ionic framework. You could build your own web components. I have a course on that. Not all browsers support everything like this out of the box, but Ionic thankfully automatically loads a lot of polyfills, which make web components work in a broad variety of browsers so that we can not just use this in Chrome, but also in Edge and in Firefox and Safari and so on. So this is a HTML element which is unlocked by Ionic. In the end, the Ionic team created a bunch of web components with JavaScript, HTML, and CSS, which we can just use. And that's important. I said it. With HTML, CSS, and JavaScript. This is how you could imagine that this button looks behind the scenes. This is regular HTML with elements, tags the browser knows in the end, some CSS code for some styling, here with some CSS variable, which we haven't used thus far, but which we will use throughout the course, and maybe also some JavaScript code to do certain things behind the scenes. Now, that's all code we could write on our own, but it's all kind of packaged up in this one element. And that's how you can think about these components. In the end, it's just code you could write on your own. It's no magic. It's just things, building blocks, the browser understands. But it makes work easier for you because you don't have to write this HTML code. You don't have to write this specific CSS code. And you don't have to write maybe some extra JavaScript code which implements some behavior behind the scenes. Instead, you got all of this packaged up, and you got a more powerful button than maybe the built-in button, which had no default styling and which maybe also lacked some other features you now have with this Ionic button. Now, this packaging up also has a name. It uses a technology called the Shadow DOM, which is one of these features unlocked with those polyfills. Shadow DOM, that's basically a feature built into browsers, which allows you, or in this case, the Ionic team, to hide certain things away from your view and let the browser render it behind the scenes. You can see that Shadow DOM in the browser if we go to the Elements tab and we, for example, select this button. Here is the Ion button, and there you see this shadow root. Now, if you expand this, you in the end see what the button does behind the scenes. You see it uses a normal button element, and you see it has a button native style, which you didn't write, but which the Ionic team wrote. So here you can see the styles which were applied by the Ionic team, and you see the HTML structure behind that button, where you see there is a span and something called slots, which we'll see in a second, and much, much more. You don't have to write this on your own, but of course it's always nice to know it. So that's Ionic behind the scenes, and that's what we're working with here. With that, back to this app, let's enhance it a little bit. Let's start by enhancing the way this looks a little bit. I actually like it, but there are a few things I'd like to improve. For example, I'd like to have some spacing around these inputs here, and I want to have the button centered. Now, there are various ways of doing that. You could, of course, add your own classes, for example, your own CSS classes. You can add those to HTML elements introduced by Ionic as well. So we could, for example, add inline styling, or as I said, a class here, which we then style with CSS to center all the text or to add some padding. But we can also use certain features that are built into Ionic already. For example, there are so-called utility classes. These can be found under Guide here. And then, if you go to Layout, CSS Utilities. There you find a couple of classes, normal CSS classes, which are also automatically loaded by Ionic, which are available everywhere, which you can use for, well, some stylings you might want to use from time to time, for centering text, or for adding some default amount of padding or margin. So, in our application here, for example, we could go to this Ion content and add a class of Ion padding here to add some padding to this application. Just by adding this class, without writing any CSS code, we now have a little bit of padding, which I personally like. Now, for this button here, we could add a div here, and then move this button into the div, so that on the div, we add the Ion text center utility class. And you find all utility classes in the official docs, of course. And by doing that, the button is centered. Now, maybe we also want to have some margin, so we could add an Ion margin here, and this will add margin in all directions, or we add Ion margin top to add some extra margin to the top here, like this. I will actually add it in all directions. So this is something we can do here. Now we automatically have a little bit of a nicer styling. There also is a built-in grid system, which you could utilize if you also want to organize certain elements in a grid layout. And maybe I want to do this. I want to add a second button next to the first one, which actually should allow us to reset the inputs and clear what's entered in the two inputs here. For that, I can, of course, add a reset button here. But if we do that and I reload, they are side by side, but maybe I want to distribute them a bit differently. That's where we can use that Ionic grid. For that, of course, we can look for that grid. Here it is. And you'll find a documentation of how it works. It basically allows you to organize content in rows and columns. And that's something you might know from other grid systems too, for example from the Bootstrap CSS library. In the end, you wrap your entire grid with the Ion grid element, and then you can have rows, and in every row you can have a couple of columns, up to 12 columns. You can also assign sizes to columns, so that if you have less than 12 columns, you can control how wide this specific column should be, otherwise they will split the available space equally. So back to our app, that means that we could replace this div here with, let's say, the Ion grid, of course also the closing element. And in there, here I have one row. And now in this row, I have my two buttons, but now every button gets its own column with the Ion col element. And you find all these elements in the official docs as you just saw. So if we now do this, and we save this, and I go back here and reload, now this is distributed a bit nicer than before. And of course, you can now also configure the grid. You could make one column wider than the other. You can change how they split the available space. I'm happy with this layout, but definitely feel free to dive into those docs and play around with the different configurations you have for aligning the items and so on. But now this looks nicer. Let's now make sure that the reset button also works and that it actually resets these inputs. Definitely feel free to do this on your own. In the next lecture, we'll do it together, and we'll then also add icons to those buttons, because I think having icons there would make a lot of sense. So we got the grid. Let's now make sure the reset button does something before we add icons. Now for that, I will give it an ID, because now we have more than one button, so we can't select this second button with the query selector, and I'll name it reset button. And to be consistent, I'll also give the first button an ID. Technically, we could still select it with the query selector because it is the first button on the page, but anyways, I will give it an ID. That's the calc button, let's say. Now back in JavaScript, we can select this first button no longer with query selector like this, but with get element by ID, and there it was the calc button. And now we got also the reset button, and there we can get it by ID, and I named it reset btn. That's the ID I assigned there. Now with that added, let's add a new function, reset inputs maybe, like this. And here all we have to do is reach out to the height input, set the value equal to an empty string, and do the same for the weight input here. Now we just need to wire that up by adding a listener at the bottom, reset button, add event listener, and it's a click listener, and listen to a click and point at the reset inputs function like this. This is again just vanilla JavaScript, but now if we go back to this application and I enter my height and my weight, and for some reason I don't want to calculate, I can press reset. And this does not work. Well, I should target the value here as well. Let's save that and reload. And this looks better. So now it resets this both, and we got these two buttons working. Now, as I said, some icons would be nice, so that we can also see a bit quicker what each button does. And when it comes to icons, we have a component for that. We have the Ion icon component, but this is a bit special. If we click on it, we're taken to ionicans.com. It's still part of Ionic. It's loaded automatically in an Ionic project, or in our case with these Ionic imports we added, but it wouldn't be uncommon for you to use Ionicans outside of Ionic projects as well. You can add those Ionic components to any project you want after all. Now here you get a bunch of icons, and here for example we could search for calculate to find a fitting icon like this one. And now click on it, and now at the bottom we see the code we can use to add this icon. And thanks to these Ionic imports which we have here, we can just add it like this and we don't need to do anything else. Now we can add this in here instead of this Ion button. There, besides this calculate text, we can add the Ion icon. And if we save this and we go back and we reload, we got the calculator here. Now that's okay, but it's a bit close to the text maybe. Now that's where we can use another concept, web component support, and which is therefore utilized by Ionic. We can use slots. Slots allow us to control where inside of a component something should be output. And Ionic uses this internally to offer us different slots we can use in a button to control where in the button exactly this should be output. Now by default it's all in the central default slot, but we could assign a different slot to the icon just by adding the slot attribute, and the surrounding element will then take advantage of this. And here, for example, we have the start slot. Now to see which slots are supported, the official docs are your friend. There, if you go to the button component, you will see a slots area, and any component that has slots will have such an area in the docs, and there you see these slots you could target, and there is the start slot. Now with that start slot, I can save this file, reload, and now you see this looks nicer. Now let's do the same for a reset. Of course, feel free to do it on your own first. I will search for reset here, and yeah, I like this icon. So again, we can just grab this here, go back to our page, go back to our code, and instead of the button, next to our text here, I will add this icon, and again use the start slot to make sure this icon is positioned nicely. If we do that and we reload, now here's the reset icon. So that's decent, that's great. We also can change the look of the button a little bit. If we go back to the button docs here, by changing its fill mode. You see, we can assign a fill attribute, and we can set it to default, or actually, as you might guess, this is the default, you don't need to set this, but you can change it to clear or outline, for example. And to see what this does, let's just try it. By the way, that's in general a good strategy. If you are not sure what something does or what some attribute does, just give it a try. You can't break it. You can always undo it if you're not happy with the result. So here on this button, on the button, not on the icon, that's important, on the button, I can add the fill attribute and, for example, set this to outline. Now we can again save this and go back to our page, and now this button looks different. And that really is the power of Ionic and web components. You can easily configure things and change things. Now with that, we got these buttons in place. That's nice. Of course, we still got no validation, but that's okay. But now we got a decent looking app here. Now, as a final step here, before we finally combine this all with React, which is ultimately why we're all here, right? Before we do that, as a final step, let's actually improve this a little bit by now finally outputting the result below the buttons instead of in the console. So finally, let's use this div here, this result div. Let's actually maybe also use that into our grid here in a separate row and one column, which then automatically will span the entire width of the row. And now here inside of that div, I want to output my result. Actually, since it is now in this column, I can give this column here an ID of result and get rid of that div. Because, as you already saw, we can target these elements, these Ionic components, with regular JavaScript. So since I only need this as, you could say, a hook to output something, to render a new element, we can absolutely use it like this. Now, in app.js, in calculate BMI, instead of console logging the BMI like this, I want to output it. Now, first of all, I'll check if this BMI is not a number. In this case, I just want to return here and not continue with the function execution so that we don't output anything if it's not a number. We could also throw an alert here and say, not a number, please check inputs. This will be a regular browser alert, by the way, not an Ionic alert. We'll learn about those as well, but later in the course. So now we got this. If we don't have not a number, so if we have a number, if we have a hopefully valid result, we want to output it. For this, let's select this result area by its ID. Here, I'll name this result area maybe, with document get element by ID, result. And in there, I want to render a new element. Now for that, we can create a new element, the result element, with document create element, not attribute, create element. And then here I want to create an Ion card. And yes, you can do that. You can create Ionic web components with JavaScript. You can not just add them to HTML, you can create them like this. The Ion card is an element built into Ionic. Here it is. It gives you this card look. We could add images and so on, but we don't need this here. I want to instead create such a card. And in that card, I simply want to output my Ion card content element, which holds the result. So, to this result element, to this card, which it is there for, I'll set the inner HTML to a template literal string here, so that I can easily inject dynamic content here and also write this as a multi-line string to make it easier to read. And there we can add the Ion card content element and also close it, Ion card content. So that's that element here. In there, I want to have, let's say, a h2 tag and also close this h2 tag, of course. And in there, we can now inject something with this syntax. And this, by the way, is regular JavaScript syntax. It's called template literal and or template string also. You can look it up if you don't know it. Attached, you'll find a link to more information about this. And in my complete JavaScript course, for example, you learn about this as well. So this is how we can inject the value of a variable or of an expression in general into this string here. And here I want to inject the BMI value, so that this is output in the card content, which is part of this card, because I set it as the inner HTML of this card. And now we just need to reach out to the result area, and there I want to add this new element, for example, with append child result element. I also want to make sure that maybe any existing elements I had in there are cleared first. So I'll reach out to the result area and set inner HTML to an empty string so that it has no HTML content, and then I add this child. Of course, there are different ways of doing that, but this should be a pretty straightforward, understandable way of rendering an HTML element dynamically with some dynamic content. With all of that, we can go back to our application, reload, enter our values again, click calculate, and here's our card. And if I change something here, for example, I change my height, we can calculate this again. Of course, we can also reset this. The card is not deleted. You could add this logic, but it's still here, but the inputs are cleared. And if I calculate this again, I get a warning here because I get not a number. So this is all working. We're now also dynamically creating an element here, which of course also is quite nice to have. However, we have missing features. For example, here we're not supporting the non-metric system, so feet and inches. And we can maybe already also see why using a library like React or some JavaScript framework might be interesting. Because we wrote a lot of JavaScript code here, and that's of course kind of the idea of a JavaScript-heavy front-end app, but we're already writing some code which we normally don't really want to write as a JavaScript developer. Here, when we interact with the DOM to add an element and to clear content, this is the kind of code we don't really want to write. We use libraries like React to define the goal and to focus on our core business logic, like this calculation here, because that's where the value of our application really comes from. The technical interaction with the document, that's really something we don't want to work on. It's easy to introduce errors here or to write code which is not that performant, like here when we always clear the existing content. That might be unnecessary to do. So we can easily mess up code here, but we also want to just focus on this code. So we can use a library like React to take away this part here and let React handle this, let React interact with the DOM, so that we can focus on the core business logic. That's why we use React in normal web apps. And in the end, this is just a normal web app where we also use Ionic. So therefore, before we have a look at Capacitor and what we can do with that and how we can get a native mobile app, Let's actually continue with this web app for the moment, and let's add React to it. Let's rebuild this with React and Ionic to see how that works, how React helps us, how we use Ionic and React, and then thereafter to also use Capacitor to turn this into our first native mobile app. Not the last one in the course, but the first one. So now that we started playing around with Ionic, and we built this first very simple application with just Ionic components and vanilla JavaScript, just so that you could get a feeling for how you generally work with Ionic, it's now, of course, time to make the next step. Because this is an Ionic React course, so in this module, we will now introduce React to the equation. We will make sure that we actually build this application with not just Ionic, but with Ionic and React. And therefore, we reap all the benefits libraries like React give us, and of course, in this course, React in general gives us. So in this module, we will see how we can create a React and Ionic project so that we can get started writing code right away. We'll then see how we work with Ionic components in React projects and how we write React code in general in React Ionic applications. And we'll also have a look at a few components we haven't seen before. And in general, throughout the course, we'll of course see more and more components. But especially important, we'll have a look at overlay components, and you will see how you actually work with those in React and Ionic, and how you can easily make sure that you, for example, show an alert to the user, a more beautiful alert than the built-in browser one, and so on. So let's get started. And to get started, we can go back to the official documentation, and there you can go to installation, CLI installation, because now we're going to use this command line interface the Ionic team created for us to create and manage projects. Now for that we need to install it, and we'll install it with a tool called npm, which stands for Node Package Manager. Now, chances are you know this tool because basic React knowledge was a prerequisite and you typically create React projects with help of npm as well. In case you don't, npm stands for Node Package Manager, and it is a tool that is distributed together with Node.js. Now, Node.js is a JavaScript runtime that allows you to run JavaScript outside of the browser, and you could use Node.js to, for example, build server-side applications with JavaScript. Now, that's not what we'll do in this course, because this course is about building frontends with React and Ionic, but nonetheless, we will need Node.js for two reasons. One reason is this npm tool, this Node Package Manager tool, which allows us to install dependencies like this Ionic CLI. So it's basically a tool that helps us install stuff. But in addition, we will also need Node.js itself, even though we're not going to write any Node.js code. Because it will turn out that the React project we create behind the scenes will use Node.js to bring up a development server which we can use to test our application. So simply go to nodejs.org and download the latest version of Node.js there, whatever version that is when you're viewing this video. So here you can just click this button, you will get a normal installer, you can walk through that installer, install Node.js, and you will automatically get this npm tool as well. Once you did that, you're ready to run this command. So let's do this. Simply open up your normal terminal or command prompt. You can use it on all operating systems and paste it in. Now, one important note, on macOS and Linux, you might be getting a permission error if you run it like this. If you do, add sudo in front of that. On Windows, you don't need to do that, and there it also won't work. Sudo is not a supported command there, and this will ensure that this runs fine. You might be prompted for your password, so if you are, just enter your system password. And now this will install this Ionic CLI as a globally available tool on your operating system. Once you installed it, you can use that tool to run some commands. And now make sure you navigate into a folder with this cd command where you want to create your Ionic React project. Now I already am in such a folder, and therefore I will now run Ionic start. And this is a command which allows you to create a new project. So I'll just hit enter here. And now here I'm asked whether I want to use Angular or React. Over time, you might see more options here, but of course I will go for React here. I also do have an Ionic Angular course if you're an Angular developer, but since you took this course, you probably are not, or at least not exclusively, and therefore I will choose React. Now next we need to assign a name, and I'll just name it Ionic-React. Hit enter, and now you got a couple of starter templates to choose from. You could, for example, start with an application that automatically uses tab navigation, but we will add this step by step on our own so that we can see how it works behind the scenes, and hence we'll just start with the blank template here. So choose blank with the arrow keys and hit enter. And now you can, last but not least, answer whether you want to integrate your new app with capacitor, and for the moment you can choose no here. We can change this later, and we will. For the moment, we'll just build an Ionic React app without capacitor, but we will add it later. So choose N for no here and hit enter. And this will now create a new project and set everything up such that you can write your Ionic React code in there. So let's wait for this process to finish. And here we are. Now you already see some instructions here at the bottom. We can now cd into the created project. In my case, into the Ionic React folder, because that's the name I chose. And in there, we can run Ionic serve to bring up a development server which hosts our frontend, our application, on a localhost address which we can use for testing the application. So we'll not be clicking on some HTML file anymore, but instead we'll use this hosted dummy application. I'm not going to do that here, however. Instead, let me open that folder with Visual Studio Code, with this IDE I already showed before. And here it is. Now, inside of that project in Visual Studio Code, I can go to Terminal, New Terminal, and open up such a terminal here. And that's your normal system terminal or command prompt, just integrated into this IDE. And here we can now run Ionic serve and bring up that development server with this way. The difference is that now I got this running server here integrated in my IDE, and if we ever should get any errors being output there, we can immediately see it whilst writing code instead of having to check a separate terminal running somewhere else. That's why I'm using this integrated approach. Now, this process which I started here will keep on running, and you should keep it running as long as you are working on your project, as long as you are writing code, because it will also watch your files, and whenever you change something, it will automatically rebuild this application behind the scenes and reload the hosted web app in your browser. And speaking of that, it should have opened up a new tab in your browser. If it didn't, you can manually go there under localhost 8100. And there you should see this dummy application running. This simple application where you got a toolbar at the top and some content in the middle of the page. And I'll open up the browser developer tools and go back to this mobile preview mode here, which I already showed you earlier. But of course, that's optional. You can also stick to the browser window, to the normal one. So with that, we got our first Ionic React app. This dummy app we got by using the Ionic CLI. And now we can explore what we have in our project folder. It's certainly more than just a HTML file and a script file, but you should already know that from regular React apps, because you know that you write code in a very modern way with your code split across multiple files using features like JSX in React. And then you got this development workflow, this development server also, where everything is bundled up and optimized and then served in your application here so that you can preview it. So the actual code we write here is actually in the source folder, and the public folder also is important because that's the single page we're working with. We don't really need to touch this a lot. Occasionally we will visit it, but this is in the end the single HTML page which will be served as part of your application and where the entire bundled up script code, which we write here in the source folder, will be hosted in. Now with that, let's close public. We also got some configuration files here, package.json for all the dependencies we're using in the project. This will grow over time when we add more dependencies. Ionic config for some Ionic configuration. We don't need to touch this at the moment. And a tsconfig.json file. And you might not be used to that. You also might see something strange if you open the source folder. Because in there, we got a components folder. We might know that. A pages folder, okay, maybe you saw that before as well. But then we got .tsx files, and that's strange. You might be used to working with .js or .jsx files. And if you open such a file, you see some familiar things, imports like this, where we import React. But then if we scroll down, this is strange. This colon after app with this thing. I mean, this is an arrow function where we return some JSX code. These probably are some Ionic components. They look different than before, but yeah, maybe that's just how it has to look. I'll come back to that. But what's this colon thing here? Why are we working in .tsx files? Here is one important thing. When working with React and Ionic, you typically use Typescript for your React application. And that is something you might not be used to, because normally in React development, you work with JavaScript. Now you can absolutely use Typescript with React, even if you're not using Ionic. But you don't see that as often as you see React with JavaScript. However, Ionic React projects use Typescript by default. And whilst you could change this, which is kind of tricky or requires some manual wiring up work, I recommend that you stick to Typescript. No worries, it's easy to learn and you will learn it in this course. So I will teach you what you need to know along the way. Nonetheless, if you like it and if you want to know more about it, I got a complete Typescript course, which you can also check out to learn all about TypeScript and also more about TypeScript and React in there. TypeScript is just a superset to JavaScript, which adds extra features to the JavaScript language, for example, types, static types, so that you can add type safety to JavaScript. And TypeScript is a language which doesn't run like this in the browser. Instead, it needs to be compiled back to JavaScript, and this whole compilation process is already included in this project setup. It happens behind the scenes, and the tsconfig.json file in the end is the file where this compilation process is configured. Now, if you know what you're doing, you can fine-tune this to your requirements, but the default setup is absolutely fine and you don't need to change anything in there. In the end, the code we write here is very familiar to the JavaScript code you already know. You can add some extra features with the help of TypeScript to write better and less error-prone code. And it automatically is compiled down to JavaScript and bundled up by that development workflow which is running behind the scenes with the help of Ionic Serve. So that is how you have to think about that. Other than that, this is a regular React application where we have a React component which returns some JSX, where we have a couple of imports. These are all just CSS imports to wire up the different styling things that we need in a Ionic application. Before we had CDN links, now we have to import everything manually here, and you should just leave these imports. And we have our index TSX file where the entire application component, the root component, is mounted to the DOM with React DOM render here. So this is how this works. Really just what you already know, just with this twist of using this extra language, TypeScript. Now, in order to get started writing some code, let's first do some cleanup work here and remove some files and code which we don't need at the moment. For example here, I will remove this service worker unregister thing, remove this import, add a new line here to make this a bit cleaner. Remove setup tests because we're not going to write any tests here, so I will remove the file, we don't need it. We could remove the service worker file. I will leave it here for the moment, but you could remove it. In app.tsx, I also want to clean up this router stuff. I will remove the ion router outlet import. I will remove this import from Ionic React router. We will add routing later, but for the moment we don't need it. I will also remove this import from React router DOM. I will leave the other imports here, leave all the CSS imports, and in here, just return an app, and in there, maybe just a h2 tag where we say this works, and we'll add more useful content soon. The theme folder holds some styling. We'll have a whole module about that. For the moment, we can ignore it. The pages folder has 2 components which we now don't need anymore, so we can remove that pages folder. That means that in app.tsx, we can now also get rid of that home import here, so that we only have these 2 imports left. We can remove the app.test.tsx file, since again, we're not going to write any tests. And in components, I will also remove all the files there. You can also remove the entire components folder for the moment. Thereafter, I will restart this Ionic serve process and save all files. And now we have a cleaned up project where we can gradually build up our app from scratch. You'll also find this cleaned up snapshot attached to this lecture so that we can all start from the same starting point. If you now reload your application here in this localhost 8100 browser, you can also remove that home segment in the URL. You should just see this works here. And this is now where we will start and where we will now migrate our project we built before to this Ionic React setup. So we got this cleaned up project. And now before we actually start writing some real Ionic React code, let me give you a brief introduction to TypeScript. In case you already know TypeScript and you know how React works with TypeScript, you can of course just skip this lecture. This here is a type assignment, and it's the most important thing TypeScript adds. As I said, TypeScript is a superset to JavaScript. You could translate this with it's an extension of JavaScript. It adds new features to the JavaScript language, and the most important feature that it adds is the feature of static types, which means that whereas you have dynamic types in vanilla JavaScript, you now have to define, or you can define, types in advance. So for example, here we are defining the type of app. A type assignment is always done by adding a colon and thereafter the type the thing in front of the colon should have. So here we're saying this app constant should hold a value of this type. Now, what is this type though? This is a type coming from React in the end. So with React dot, we're accessing the FC type in there, and that's simply coming from a React type package, which already was installed for us here in package.json. You can see it. It's this types package, which basically adds type definitions to the React library, you could say. Those packages exist for all major libraries. And we're saying, okay, this constant app should hold a React FC type. Now, this actually stands for functional component. And again, it is a type predefined in this special types package, which already was added to this project by Ionic start, by this command we used to create the project. This is simply one of the built-in types which is provided by this types package. Now, it defines that whatever we store inside of app has to be a valid functional component. And what is a valid functional component? Well, it has to be a function, of course, and it has to be a function that returns JSX, and that's just what this function here does. That's why it fulfills this requirement. If I would temporarily cut this, and for example store a string in there, I get an error, as you can tell. Now, normally, without this type assignment, this would be valid JavaScript code, right? It would not work in a React app, it would not bring something to the screen, but from a pure JavaScript code perspective, this, without the type assignment here, so like this, would be valid JavaScript code. It would just be a string stored in a constant. With that type assignment, however, it becomes invalid, not in JavaScript world, because JavaScript doesn't know these types, but in TypeScript world. And as I mentioned, the TypeScript code will be compiled to JavaScript, and during this compilation process, the TypeScript compiler will check for errors like this. And Visual Studio Code is actually a TypeScript-aware IDE, which is why we already see that error in the IDE even before compiling. The compilation would only happen once I save this. Now this rebuilds, it compiles as you can tell, and normally you should see the error down there. Unfortunately, this is a bit buggy and therefore it's not showing the error down there, but we still see it in the IDE. Here we see that the type hello, so this text basically, is not assignable to the type functional component. So we have to revert this to bring back our functional component to have a valid code snippet here. And this is the feature TypeScript adds. Now, of course, you can add types everywhere, not just on constants that hold functional components. And of course, there also are more types than this functional component type. There, for example, also are some default types like the string type. With this, I would be saying that title should only hold a string. And then here I did store a string, so this is valid. My IDE here only complains because I'm never using this value. But from a type perspective, this is correct. If I would use the built-in number type instead, and string and number and boolean are default types TypeScript ships with, then I would be getting an error again, because this clearly is not a number. So this is the idea behind TypeScript. Again, you can take my TypeScript course to learn more about it. Otherwise, I will teach it here along the way, step by step. Now, of course, we need no title here. We only need this functional component. And there, I do return this ION_app. I mentioned that we have one ION_app component per application, if you remember. And in there, I have a regular h2 tag. Now, since I introduced you to TypeScript, let's now move on to using Ionic in this React TypeScript application. How does that work, and how can we get closer to this Ionic application we already built before? We got the ION_app component here. And if you compare this to the Ionic app we built before, in the module before this module, you might notice an important difference. Here, ION_app looks like this. We have this notation where we have starting capital characters and only one word without a dash. Whereas before, we used these components which looked much more like regular HTML elements. Now, we use this syntax here in Ionic React because we're not writing normal HTML code here, but we are using JSX code here. And it turns out that JSX doesn't support web components like this out of the box. You need some fine-tuning there, and that's some fine-tuning the Ionic React team already did for us. If we scroll to the top of this app.tsx file, we actually see that we're importing ION_app from @ionic/react. And that's important, we're importing this. This turns out to be a React component, which we therefore, of course, can use, like we can use our custom components, in the JSX code. So these HTML components, which we can also use, like h2, there we really can only use the default HTML ones, not the web components unlocked by Ionic. Those Ionic components have to be imported from @ionic react, just like we're importing our own components from other files, you could say. This simply has technical reasons in React, and the Ionic React team gives us this Ionic React package where we in the end have these wrapper React components which wrap these Ionic web components and wire them up behind the scenes so that what we use behind the scenes is still this. We're still using the regular Ionic web components, but we got this React component wrapper for all those components where we then just work with those React components in our JSX code. Now, the translation from this to this, of course, is easy. You omit the dash and you start every word in a word with a capital character. So ION_app written like this, all lowercase with a dash, becomes this without a dash, where the I and the A are in capital case. And that will hold for all those Ionic web components. The important difference here between React components and Ionic components is that React components, of course, are created with the React library They are typically created as functional or class-based components, and you use JSX there to define what React should render to the DOM in the end. And of course, they're only usable inside of React apps. Ionic apps, on the other hand, are these pre-built web components built with vanilla JavaScript following browser standards. They use native web technologies, therefore, and they can be used anywhere, but the React library is a bit picky about this, a bit special, and therefore, in order to use web components there, some wire-up work needs to be done, and that's the work the Ionic team did for us when it created that Ionic React wrapper. This wrapper, in the end, just makes sure that these Ionic web components, which is provided by the Ionic core package, are actually wrapped into a React component, and those wrapped components are then provided by Ionic React. So we'll only work with these wrapped React components, which under the hood use the normal Ionic web components. But we'll work with these wrapped ones for technical reasons. Now, besides these technical reasons, we also get a better development experience with these custom components. We get better auto-completion, for example. Certain React features are unlocked with that, are wired up behind the scenes. And in general, it does this technical work I already referred to. I just highlight this so that you know why now all of a sudden the components look different. Behind the scenes, we're still working with the web components, just wrapped by the Ionic team and exposed in the Ionic React library. So with that all out of the way, let's now actually write our application here. And to get started, I just want to port this old application here, which we wrote with just Ionic and JavaScript, to React. Now for that, we of course need two things in this Ion app, and that's our Ion header, opening and closing, and also our Ion content, opening and closing. Now important, we can't just use these components like this, we need to import them. And that's really important. You will need to import all the Ionic components you want to use inside of a React component from @Ionic React. So here we need the Ion header and the Ion content. Now, Visual Studio Code actually will automatically add these imports if you press enter at the right point of time, but here I wanted to show you that you need these imports. Now in the Ion header, we can add an Ion toolbar, and now that's what I meant. Once Visual Studio Code suggests this, you can hit enter, and if you do that, this import should have been added automatically by Visual Studio Code. If that's not the case, you need to add it manually. So we need the Ion toolbar, and in there, we have our Ion title like this. Again, I hit enter, tab, by the way, also works to automatically add this import. Now in this title, we had BMI calculator, so we can just copy that, move it over there, and put that between our title tags. And now in the content, there we got our two Ion items, and then we got this grid. Actually here, I will move everything into the grid. Technically not required, but I feel like doing this. So I will add the Ion grid. Again, hit tab to automatically add the import with the Ion row here. And in there, a Ion column. And now in that Ion column here, I will add this Ion item. So we have an Ion item here with an Ion label. And then below that, a Ion input. And I'm constantly hitting tab or enter here. If you don't do that, add all these imports manually. You see this is also getting very long here, so that's a great place to hit this format document shortcut so that this is split across multiple lines and easier to read. With that, let's go back down there. And then on this first input, I had your height as a label. So let's copy that into here. Let's add this position attribute, and that's now where you see this improved development experience I was referring to. We get auto-completion here thanks to React and TypeScript, and you see there is a position prop, and once you add the equal sign and the quotes, you should automatically get those suggestions here regarding the valid values you can fill in. And that's of course amazing because it often saves you a trip to the docs to find out which values you can use. Here we just see it in the IDE. If you don't get this, by the way, you can try pressing Control Space, and you should also open this Auto Suggestions menu. So here I'll pick floating. So with that, we got the height added. Now I will copy this and add another ion item. Here we have your weight. Side note, I don't add this ID which we had on the input because I'll get that value from the input differently now that we're using React. And also one important thing, I will actually grab this ion item and not add it in the same column and row, but instead add a new row and a new ion column and add my new item with the second input there, just to really use this grid correctly, where we should, well, work with rows and columns in the way that makes sense. We have two inputs that should be in separate rows, so of course in the grid they also should be in separate rows. So that's that. Now I did have ion padding on the content. I still want that. So on the ion content here, we add a CSS class, but since we're in React, not with class, but with class name. And that has nothing to do with Ionic or with Typescript. This is regular React. So we add class name and then ion padding here to add this padding to this entire content area. Now let's continue working on this. We now also got these two buttons. So below the inputs, we add a new row with a new column here, a new column. And in this column, I'll add a button. Of course, here again, make sure you add the import or you press tab or enter correctly for the IDE to add the import. And in this button, you might remember, we had this icon. So again, we use ion icon here, like this. We can use this as a self-closing tag because there will be nothing between the opening and closing tag. And then here we had a name of calculator outline. So I'll copy that and add this here. And next to this, I have the calculate label. Now I'll copy that entire column and add it as a second column next to the first one. And here we had reset and the refresh outline icon here. So here I will use refresh outline and reset and use those slots. That's also supported in React because again, these React components are just wrappers. So here we can add slot and set this to start here. We don't get auto completion here because the IDE doesn't really understand that this belongs to the slots of the outer elements, so it can't predict which values are allowed by the outer element. So that's something we'll have to look up in the docs. And we do this here as well. Again, I will omit all IDs for now. I will also omit the text centering for the moment. Instead, on this first column here, I will add ion text left, and on the second one, ion text right to have a bigger distance between these two buttons. But that's ultimately totally up to you. With that, we're getting closer to our final result. Now we just need a row and a column for the result we want to render. So let's add ion row and ion column. And again here, I will not add this ID because we will output this result card, which we previously created programmatically with JavaScript, differently now that we're using React. Because the whole idea behind React really is that we use this declarative approach where we define the JSX code that should be output, and then we can define different conditions when something should be rendered, and React will be responsible for figuring out the way to get there and for doing the steps to bring something onto the screen or remove it from there. So we can save this now. And here I will restart Ionic Surf because it crashed before. Wait for this to restart. And back in the browser, if I reload here, we have this look. Now, one important thing we can see right away, the icons are missing, right? And we get a warning regarding that as well. And there's one important thing you have to know about using icons in an Ionic React project. You don't use them with the name attribute as you do it in a regular Ionic project, but instead differently. Instead of using that name, you use the icon attribute the icon prop, we should say, in React, which we can set here. And we don't set this to a string, to a name, or to some text. Instead, we set a dynamic value here. Hence, we need single curly braces to inject something dynamic here. And the thing we're injecting is something we import from an extra package. We import something from Ionicons/icons. This is an extra package which is installed by default. You see it in the package.json file. Here it is. And this basically gives us all these icons available in this application, and we just have to import those which we want to use in this specific component. Now here we had that calculator outline icon, and you will see that from there you can import calculator outline, now written like this in camel case. We will also need the refresh outline, so we can already import this icon as well. So these are the two icons we're importing here. And now down there on the icon components, we point at calculate outline here. And on this second icon, we have icon equals refresh outline. Just like this. And that's just one pattern you have to memorize. In Ionic React, this is how you use icons. And if we now save that, it rebuilds, and now you see those icons here. This now, visually, is pretty close to what we had before. Color is missing in the toolbar, and the logic is missing. So that's what we'll do next. Of course, feel free to do this on your own, because all you'll need here is really just default React knowledge. We'll now do this like we would always do it in React, but of course we'll do it together in the next lecture. So, were you successful? Let's do this together. For that, back in our code, we gotta do a couple of things. We have to wire up those buttons to functions, and in those functions we need to interact with the data entered by the user to either clear these inputs or to calculate a result. Now, for that, we'll do this like we would always do it in a React app. Side note, here in this course, I will only work with functional components and React hooks. I do teach that, and also the other approach with class-based components in my React The Complete Guide course. But again, I will focus on this functional components with hooks style here. So if you're not fully sure about that, make sure you first pick up the dedicated sections in my React course or some other resources where you'll learn about that. That being said, here we are in a functional component, and now we first of all need to define two extra functions inside of this React functional component function, which we can bind to our buttons. We have the calculate BMI function, and I will define it as an arrow function here. And we have the reset inputs function. Now you can already tell my IDE is not too happy, and the reason for that is that now this previously was just an arrow function where I returned just the JSX code. Now I'm adding more stuff to the function body, so we have to change the signature of this functional component arrow function. Instead of a bracket, which just wraps the return value, we now add a curly brace, and we add a closing curly brace to wrap our function body. And now this JSX code has to be returned, so we add a return statement here. And to support multi-line code, we wrap this into brackets now. And then we can press the auto format shortcut. Now that's working. Now we got these two functions here. Now we can wire up those functions, and we do that just as we would always do it in React. Here on this first button, we want to wire up the calculate BMI function. We add the onClick prop for that. The onClick prop is available on the default button component. It's also available on the Ion button. And you can see this in the official docs, of course, also, but also here with the auto completion. Basically, all those default button props are forwarded here to the Ion button. So we can add onClick and point at the calculate BMI function. Important, just point at it, don't execute it here, because we want to store the function itself, this function object, in the onClick prop, so to say. We want to pass on that function object to the onClick prop so that React and the browser can invoke this function for us when a click happens. If we would add parentheses here, the function would be executed right away when this code is parsed, and the return value of the function here, of this function execution, would be passed to onClick. That's not what we want. We want to pass the function itself. Let's also do this on the second button here and point this at the reset inputs function. Again, just at the function, not at the result of the function execution. That's the first step. Now we need to get the values the user entered in the inputs. There are various ways. We could set up two-way binding, where we listen to changes to the input and store the entered value in a state, or we use refs, a concept available in React, and that's what I'll do. To use refs in functional components, we need to import a hook from React by adding this import here, and that's the use ref hook. It's written like this, use ref, and this allows us to set up a ref. Again, that's just a React concept which I expect you to know. It has nothing to do with Ionic or with Typescript. Refs are a React concept, and with the use ref hook, you can set up refs in functional components. So we create two refs here, wait input ref with use ref here, and a second one with height input ref with use ref. And these refs can be assigned to elements in the JSX code so that we kind of establish a connection to those elements and we can retrieve values somewhere else in our JavaScript code with help of those refs. For that, let's go down to that first input, which is the height input. And there we now add the ref prop, which is available, and we point that at the height input ref. And then here on that second input, we add the ref prop and point this at the weight input ref. Now here I'm getting an error, and this is now an error which we're only getting because we're using Typescript. It's a pretty long cryptic error, but we see that the expected type comes from property ref, which is declared here, blah, blah, blah. Now that's just something you have to be aware of or you have to know when using Typescript, which is why I'm telling you it here. Use ref like this creates such a ref object, but Typescript doesn't really understand what this reference will point at once we use it. Here in this line, when the ref is created, Typescript has no chance of knowing that this eventually will be connected to this input down there. And therefore, when we do so down there, Typescript basically says, well, this height input ref, I didn't know that it should be connected here, and hence, when you use it up here, I won't be able to support you correctly. So we have to let Typescript know to which kind of element will eventually connect this ref. And we do so by using a special Typescript syntax. We add angle brackets after use ref, and between them, we add HTML ion input element. Now what's that? The angle brackets can be used because useref supports so-called generic types. This essentially means that the type of data the reference we're creating here is flexible. It's not set in stone. We could also store something like a string or a number or an array in a ref. It doesn't have to be a DOM element. But even if it is a DOM element, it's flexible regarding which kind of DOM element. And here we're saying, well, this ref will eventually hold a pointer at an ion input element. And this HTML ion input element thing here, this is just a TypeScript type provided by Ionic. We don't need to import it from anywhere, it's globally available. It's a core type which is available when we work with Ionic and TypeScript, you could say. And this now lets TypeScript know that this ref which is created here will eventually point at an ion input element. Now, still TypeScript wouldn't be happy because initially when we created, so when this exact line here, line 39 and line 40, when these lines are parsed, of course no connection has been established yet. That's why we also have to set a default value for this ref, which is null, which means initially it's not set to anything, but eventually it will point at an ion input element. This is what we're saying with this syntax here. Now, what does this tell Typescript? It tells Typescript that eventually this reference object will point at an object of type HTML ion input element, which is just the underlying Typescript type this ion input object, which is created in the end, has. We also tell Typescript that the initial value is null, because at the start of this function execution, of course, no connection has been established yet. Now, once this return statement has been executed, these connections have been set up with the help of the ref keyword, and then everything is fine, because then Typescript also knows that the ref we're using here, the height input ref, is actually configured to be connected to an ion input element, which is just what we're connecting it to here. I know that this can be tricky to wrap your head around. To be honest, it's thankfully one of the most complex things when it comes to React with TypeScript, and we already got this out of the way now. As a rule of thumb, you can just memorize that if you're working with refs and you're using them to connect to an element in your JSX code, you have to set up which kind of element you'll be connecting to and initialize them to null. And that's basically it. With that, we set up the connection to the height and the weight input ref. And now here, in calculate BMI, we can extract our two values. We can get the entered weight by accessing weight input ref. And now here, .current .value. And do the same here for the entered height. And you might have seen that there was something inserted by my IDE when I typed value, this question mark. Now, why was this question mark added here? This is a special TypeScript syntax, which in the end is a shorter form available in TypeScript for writing a ternary expression, where we first of all would check whether weight input ref current holds a non-null value before we then try to access the value property. Now, why would we need such a ternary expression normally? Well, because, of course, current could point at a null ref, right? Initially, the ref holds null as a value. We set this up in lines 39 and 40. Now, of course, we as a developer, we know that calculate BMI, this function, will only run after the connection to the real DOM elements has been established in our JSX code. But TypeScript can't know that. It doesn't know that this code necessarily runs at a point of time where the references will not be null. That's why TypeScript would want us to add such a ternary expression to rule out potential runtime errors when we try to access the value property on null, where this would indeed crash at runtime. Now, that's why we need a ternary expression, and using this question mark syntax is just a shorthand form where TypeScript will check whether current holds a non-null object, and only if it does, TypeScript will access the value property. So in the end, it's a shorthand form of this longer ternary expression, and behind the scenes, once the TypeScript code is compiled to JavaScript, it most likely is expanded to a full ternary expression. So it's really just a shorter syntax available in TypeScript. If you know with certainty that by the time this is going to execute, this connection will be established and this will not be null, you can replace the question mark with an exclamation mark. This tells TypeScript this will never be null, you can always access the value, I guarantee it. And we can safely do this here because we're writing this code and we know this function will never execute without the connections between the refs and our JSX code being established. So we know we'll always be able to access our ref and extract the value, hence we can add the exclamation mark, and as a result, the value returned by this will never be null. It might be an empty string if the user didn't enter something, but it will never be null. This is just some TypeScript specialty which adds extra safety and avoids unwanted errors where you have to be really clear about your code and how it's going to execute, and you deliberately have to tell TypeScript, I'm sure this will always be set, which forces you to reflect about your code and maybe fix eventual bugs you might have introduced. Here, everything is fine, we know this will never be null, we can always safely extract this value. And with that, we got the entered weight, we got the entered height, and now we can calculate a BMI by dividing the entered weight by entered height times entered height. And we face the next problem. And that's really the good thing about TypeScript. It warns us early about problems. And what's the problem here? Well, if we hover over it, we see that this must be of type any, number, or big integer, or an enum type, whatever that is. But this actually is a string. We have to add a plus here to convert this back to a number, but now we're getting an error up here that this is possibly null. Now I said that this exclamation mark means it can never be null, but the problem is it means that this connection with the reference will never be null. The extracted value still could be null. We can add another exclamation mark here to basically tell TypeScript that this also will never be null. However, we can't guarantee that. It might end up to be null, or actually an empty string, in which case we would also have a problem. So I will switch to a different solution here and check if entered height is falsy by adding an exclamation mark in front of it, or if entered weight is falsy, and that will be true if it's null or if it's an empty string, then I'll return. So we'll only continue with the function execution when entered height and entered weight are not null and are not empty strings. These two conditions have to be met. Only if it's not an empty string and not null will make it to this line. And then I will convert these inputs here to numbers down there by adding a plus in front of them. Now it could still be a string like hello. That's something we're not catching here, but it certainly won't be null. And with all of that, let's console log the BMI here for the moment to output it. Let's also implement the reset inputs function and clear these inputs. For that, we can again use our refs. So we can again use the weight input ref, current, and set value equal to an empty string, and repeat that for the height input ref. Now again, we're getting an error for the same reason as explained before. TypeScript doesn't know if that code could run without a connection being established and the reference pointing at a real object. And therefore, we have to tell TypeScript that this will never be null by adding an exclamation mark. We're telling TypeScript this code will never run without a valid object being stored in this reference. This will always be the case when this code runs, and we can guarantee this to TypeScript because we're writing our own code. We know that the only way the reset inputs function runs is by clicking that button, and that can only happen after this JSX code has been parsed and therefore after this connection has been established. So there is no way for this function to run without an established connection and therefore without a valid value stored in the reference. Now, you might be wondering, after all these exclamation marks and question marks, why is it so important to TypeScript that this is not null, that weight input ref current is not a null object? Well, it is so important because if it would be null and we would try to access a value property, as we're doing it here, on null, we would get a runtime error, right? That's how JavaScript works. Accessing a property on null or undefined gives you a runtime error. TypeScript wants to prevent us from such errors. And that's why it's pointing us at all these code snippets that could potentially cause such a runtime error if something would be null. Now, as I said, we as a developer, the way we wrote this code, we know this can't be null. We know reset inputs is only going to run after the JSX code has been parsed and this ref object has been set to the input element. We as a developer know this. TypeScript doesn't know it. It doesn't understand enough about our program to know this. So that's why we as a programmer can convince TypeScript that we know better by, in this case, adding the exclamation marks here, which basically tells TypeScript, don't worry, I'm sure current will never yield null. It will always yield a valid object. This is why TypeScript does this and why we add this exclamation mark and so on. So with that, we're clearing this. And now finally, if we save that, we go back to our application and I enter values here. I can click calculate and I see my result here in the DevTools. And I can click reset and it resets. So that all works. However, now you see when I try it a second time, I get not a number here. We'll have to fix that. And in general, we'll have to fix some minor issues. Here the problem was that I added a comma instead of a dot. So we're not fully there, but we got started, and we're now calculating this in a React way with the help of refs and with the help of TypeScript, with these extra things you have to watch out for when it comes to ensuring that you're not working with a null value or with invalid values. In general, with TypeScript, you simply have to be more explicit about the code you're writing, your intention, and you have to rule out that your code runs in certain cases when a certain value might not be set, and you would be getting a runtime error if you try to, for example, retrieve value on a null object. That's why you have to reflect about this and deliberately tell TypeScript that this will never be null, which forces you as a developer to really check your code and ensure that you're right about this statement and that this code can't run without an established connection through the ref. And in this case, this code should be fine. Now, let's focus on the next steps. So we are retrieving our values. We are calculating a body mass index. Now, let's continue working on this application. And for that, I don't just want to log the body mass index here, but just as before, I want to output it below our inputs here. Now, previously, in the app where we didn't use React, we did that by manually creating an Ion card element, setting its inner HTML content, and adding this to the DOM. Now, one of the big reasons why we are using libraries like React is that we don't want to do that. We don't want to write those manual instructions. Instead, we want to let React figure that out and just define the result, the goal. React's job is to find out the way to reach that goal. So here, translated to React, that means that here in this Ion column, we want to eventually render an Ion card. So we can add this and hit tab to automatically add this import. And in there, we want to have an Ion card content with a h2 tag in there. And that h2 tag should hold the calculated body mass index if we have one. So for that, we need state. We need to be able to change the data in this component dynamically and reflect those changes in our JSX code and therefore in the DOM. And that's where we need state in React. In functional components, we can manage state with the useState hook. So let's import useState here. And then in the functional component here, we can call useState. And the state I want to manage here is the calculated body mass index. And initially, I set no value here because initially that's just undefined. Now you know that useState returns an array with exactly 2 elements. So we can use array destructuring to get those elements out of the returned array. And the first element is always the current state snapshot for this render cycle, so to say, for this function execution. And here that would be our calculated BMI, for example. You can name it however you want. And then the second array element which we extract is a function that allows us to update that state. And therefore you typically name it set calculated BMI in this case here. So now we got these 2 values, and now here, instead of console logging the BMI, we can call set calculated BMI and pass the BMI to this function. Now, as a little side note, to improve TypeScript support, we can also configure useState a bit differently. We're not getting an error here, but we can tell TypeScript in this line already, so before we ever set any state to it, that the state we're eventually going to store in there will be a number. We again do this by using this generic type feature with the angle brackets, and then we set this to number like this. And this tells TypeScript that the state we're going to manage here, the data we're going to manage in there, will eventually be a number. It's also allowed that it's undefined initially, but when we set a value to it, it has to be a number. That's what I'm doing here. I'm passing in a number. If I would pass in a string here now, I would get an error that the argument of type hello is not assignable to type number in the end. So that's a little bit of extra TypeScript support here, which helps us write cleaner code and be more explicit about the types of data we're working with. Now, with that, we of course also only want to render this entire row here if we got a calculated body mass index. And we want to output the body mass index in here. So for that, we use single curly braces and refer to the calculated BMI. But as I said, the whole row should only be rendered if we have a BMI. And you know how that works in React. If you want to render something conditionally, you wrap it in curly braces, and then you add a conditional expression here. So here, for example, we check if calculated BMI, this here, if this is set. And if it is set, so if it's not undefined, if it's not falsy, we'll output this row here. This is how you can do this in React. You could also write a ternary expression here, of course, and say it like this, render nothing if it's not set, but you can always shorten this to this syntax and use this vanilla JavaScript way of expressing a concatenated conditional expression where the second result will be returned by this overall expression if the first part of the concatenated expression here is truthy. So if this is truthy, this will be rendered to the DOM. And now with that, if we save this, and I again enter my height here and my weight, and I click calculate, you see this card down there. If I reset this and I click calculate, you still see it because we currently have no mechanism of clearing this or of doing anything else, but we have the same behavior now as we had it in this application before. But now in a totally React-ish way, where we only define the result and different scenarios, different conditions like we do it here, and React is responsible for actually writing something to the DOM or removing something from the DOM. This is our first simple Ionic React app with TypeScript mixed in, which can make things more complex if you're not used to it, but you will get used to it quickly. Now, of course, we are not done yet though. We can improve this application in many regards, and we can also improve it from a code perspective and split this huge component we have here into smaller components, because that's what we typically do in React development, right? So before we improve this application in any way, we can split this big app component into smaller components. Now it's totally up to you how you want to split it, to be honest. There are many possible ways of doing that. I want to create a couple of components to show you how you use this normal React approach of splitting your app into components in Ionic React apps as well. For example, I will outsource these controls here into a separate component, so these two buttons. And I will also outsource this result into a separate component. So in the components folder, which we already have here, if you don't, you can just create it, I will add a new file and I will name it bmicontrols.tsx. .tsx is the extension you should use here to use TypeScript with JSX. And I will add a second file, the bmi result.tsx. Now in app.tsx, I can grab this row with the controls, with the buttons, cut it, and go to bmi controls, and first of all, import React from React. You need to do that to use JSX. Then here I create a constant, bmi controls, that's my component name. It will be of type react.fc. You assign that type with a colon as you learned. And then it's a regular arrow function, but an arrow function that needs to return JSX. So here I will just put my cut JSX code between these brackets. And then I also export this bmi controls function here as a default indet file so that we can import it into other files. Now, of course, we now need to add all those imports here. So we import from @Ionic React, and there we just add all the components we're using here. So we import ion row, we import ion call and ion button, and also ion icon. We also need to import these icons we got here. So we import them from ionicons/icons. From there, we import calculator outline and refresh outline like this. And now we just need to make sure that we also wire up our buttons to the functions in the app component. Now, we of course do that in the way we always do it in React. First of all, in the app component, we can get rid of these two components which we don't need anymore, get rid of the icon imports, and instead add a new import here where we import BMI controls from /components BMI controls, and you omit the file extension here. Now that's our own custom component, so in our JSX code, we just add BMI controls like this. Now here, we now need to pass pointers at these two functions we got here down into the BMI controls component. That's how we do that in React, how we basically connect buttons or whatever we have in a child component to functions in the parent component. So, since it's our component, we can define how we name those props. We could have on calculate prop, where we point at calculate BMI, and on reset prop, where we point at reset inputs. Now the problem is, of course, these two props don't exist on this component. In regular JavaScript, you wouldn't get an error here because you're just setting some props which don't exist. That's not a technical error. But TypeScript forces you to write cleaner code. It also wants to avoid that you make typos, for example. So maybe we just mistyped the prop, and in that case we would quickly see that because we have the red squiggly lines here. In this case we didn't mistype, we just don't have such props in the child component. So we should go to BMI controls and let TypeScript know which kind of props we want to support there. For that we accept props here, of course, and then here on a click on this button we want to execute the function we receive in onCalculate, right? That's the prop name we chose here, onCalculate. We want to use that here. And here on the reset button we want to trigger the function we receive on the onReset prop. Right here we got onReset, it points at the reset inputs function, so this function is forwarded to BMI controls. We want to execute it via that prop where we receive it when this button is clicked. But we still get an error here. Property onCalculate does not exist. Well, that's TypeScript. You always have to be explicit. You have to tell TypeScript in a more explicit way which kind of props you want to support in this functional component. And you do that by also using the fact that this FC type, this React FC type here, also is a generic type. We add angle brackets here, and between those brackets, we define the props object this will be. So the types of data we get on this props object. For that, we can add curly braces here to define a JavaScript object, but now not a new object as a value we can use in this function, but as a type definition for TypeScript. And there, TypeScript always knows we will have a children prop, which is this special prop we have in React to get the content between the opening and closing tags of a component. But now we can define that there should be an onCalculate prop, and this should be a function, right? And to let TypeScript know that this should be a function, we define a so-called function type, which looks like this, for example, like an arrow function, but again, this is not a real function we're defining, but the type definition of a function. This says onCalculate will be a function which receives no arguments, or which wants no arguments, and which will not return anything. Why it means that a function doesn't return anything. And we'll not just have the onCalculate function here in our props object, but instead you add a semicolon, not a comma, but a semicolon. Comma also works, but semicolon is better to make it clear that this is now not a JavaScript object we're creating, but a type definition for TypeScript. And there, when you define object types, you separate your properties with semicolons. So then now we add a second property here, and that's the onReset prop. And this also will be a function that returns nothing. If we now hit auto format, it's reformatted to this. And now we're telling TypeScript that this custom component here will receive props, which looks like this. So an object where we always have a children prop, that is wired up behind the scenes, but where in addition to that built-in children prop, we'll have a onCalculate prop, which will point at a function which takes no arguments and which doesn't return anything, and a onReset prop, which points at a function that takes no arguments and doesn't return anything. Therefore, now this can be wired up here, and in app.tsx the error also is gone. This is how you do that in TypeScript and React. Now, for the result, I will cut this row here, go to BMI result, import React from React, of course, like before, define my BMI result component, which is of type React FC, as you learned. And then here, we export this, of course, as a default BMI result. And in the functional component, we return that JSX code I just cut. And just as before, we now also need to import from @Ionic React, we need to import those Ionic components we're using here. Ion row, Ion call, Ion card, and Ion card content, of course. Now here, the value I'm outputting, that of course should be received via props. And there, it's up to you how we name this. Here we could have the result or the value prop, whatever you want. I'll go for a result. And again, we use this generic type to let TypeScript know how our props object should look like here. We want to have a result key in there. And the value now, of course, is not a function, but just a number or a string, you could say. This will work with both. And here, this is how you define multiple types in TypeScript. You're saying the value here will be of type number or with a single pipe symbol of type string. Both is allowed because both will work here. So now with that, we got the BMI result back in the app component. We output BMI result. Now, make sure you add import. For me, it was automatically added here. I'll add it here at the top. I like this better. So make sure you import your BMI result component. And then here at the bottom, we got the BMI result. And now we set that result prop and we point this at calculated BMI. That's what we forward. Now with that, we can again clean up the kind of Ionic components we're importing here in the app component. We're not using card and card content anymore. And with that out of the way, if we save everything, this should still work as before, but now in a more React-ish way, where we distributed this across multiple components. And you also saw how you integrate this into the TypeScript world by defining the type of data of your props object. Now that's that. Now let's work on improving this application a little bit by also checking the user input a bit better, making sure that invalid data is not used, and by also making sure that we show an error message to the user if something invalid is entered. So let's improve this application a little bit. I'll start by configuring some Ionic components. For one, I'll add something which we had before on the toolbar, and that was the color. We had that before, I will re-add it here. We can simply set the color prop here to primary again, just to make sure that we have this blue toolbar. Looks a bit nicer, I think. Now, in addition, I want to also change the input types here on Ion input. I will set the type here to number to kind of restrict the user from entering something which is not a number. If we do that, you will see that if I try to type hello, this shouldn't work here. I can enter a number like this, however, and that will now both work, no matter if I write it with a dot or with a comma. So that's another improvement. Now, I also want to make sure that the user doesn't enter 0 here, for example, though, because that doesn't really work the way I want. So for that, we don't just need changed configuration in JSX, but also more logic here in our calculate BMI function. To be precise, I want to check if entered height, here we're checking if it's not null, that's good, but I also want to check if entered height or weight is negative or 0, because both doesn't make sense here. So I check if entered height is not a thing, or entered weight is not a thing, or if we made it past these two checks, I'll check if entered weight is, if I convert it to a number, smaller or equal than 0, and the same for the entered height. Conversion to a number is important so that we don't check this for a string where this wouldn't make sense, but we check this for the converted number. So check if that is smaller or equal than 0. We could also check if, once we convert it to a number, it's not a number with is NaN, but we shouldn't really have that scenario here since we configured the inputs to be of type numbers, so the user shouldn't really be able to enter a string here, at least unless he uses the dev tools to do something fishy, in which case we're fine with breaking this app, I guess. So these are checks I want to add though, and with that added, we ensure that if I enter 0 here, nothing happens. Now that's better than outputting a wrong result, but it would be even better to show an alert to the user. And therefore, let's see how we can display such an overlay component to the user. Now, of course, we could show an alert by adding alert here. This alert function, which is built into the browser, where we say, please enter valid non-negative numbers. We could do that. And if we save that and I hit calculate here, I get this alert. But this is not super pretty. It's the default browser alert. Doesn't look that great, right? So to improve this, we can go back to the documentation. And there, let's dive back into the components. And you will notice that there is an alert component, the Ion alert. And in the preview, this looks quite promising. Now, how do we use this alert? As always, you can read through the docs to learn all about the configuration you can add, and you can see different examples with different frameworks and libraries, and we're of course interested in React. And what you see is that you just import Ion alert from Ionic React, and in the end you then just render the alert conditionally. So it's a very React-ish way of displaying this. You just render the component when you want to display it, you don't render it if you don't want to display it. So, back in our code, that means that here in the app component, we're just importing Ion alert here, like this. And now, in our app component JSX code, we display this alert if we're not happy with the entered values. Now, we can add it anywhere in this JSX code because it won't be rendered in the normal JSX DOM element hierarchy anyways. Behind the scenes, it will always be injected somewhere else. So we can also add it here at the very top, Ion alert. However, you know in React, multiple root level elements are not allowed like this, so I will wrap this with React fragment, which is this component built into React that allows us to have multiple side-by-side root level elements without really having them as root level elements, because we actually have this as a root level element, but this doesn't render anything to the DOM. It's just there to fulfill this technical requirement React has, which is that you must only return one root level element in your JSX code. So now with that, we have the Ion alert here, and we're getting an error. For example, that the property isOpen is missing. You need to set this to tell the alert whether it should be visible or not. So here, we can set isOpen, and we want to show this if we have an error. So, in the end, in order to determine whether we have an error or not, we can use state management and set an error state here if we make it into this if statement. So let's go here to the top maybe and call use state again to have a second piece of state we manage in here. You can have multiple ones, as you know. Extract values from there, and that is our error and a set error function. Now initially we have no error. Initially that's undefined, but eventually that will be a string, let's say. So we use this generic type feature to let Typescript know which kind of data will eventually store in there. Either undefined, that's always an option, or a string. So now here, if we make it into this if check, before returning, which I still want because I don't want to continue with the function execution, I will call set error and set my error message here, which is please enter a valid input value or input number. A valid non-negative input number. So now we're setting this error state, and with that here, we check if error is truthy. If it's not null, we want to show the alert. However, for that, we need to convert error, which is a string, to a Boolean, because isOpen wants a Boolean value. And we can do that in JavaScript and also in TypeScript by adding double exclamation marks here. This converts this falsy or truthy value to a real true or false Boolean. So if this is a non-empty string, this here will yield true. If it is an empty string or undefined, it will yield false. So isOpen will be true if this is anything but an empty string or undefined. So now we'll show this alert in such scenarios. We can actually convert IONAlert to a self-closing component here, by the way, because all the configuration will happen via props. Because now we can also set the message that should be shown. And that, of course, is the error. Error is a string. Message wants a string, so that's fine. We can also add buttons that should be shown on that alert. Now, buttons takes an array where in the simplest form you just have an array of strings, which is the text of the buttons. You can also have an array of objects where every object then defines the text of the button, the role, which controls which color it has, and the handler function. And that's what I'll do here. I'll add a text here of, let's say, OK, and then my handler function. Now, if you wouldn't use this approach here, instead if you had an array of just strings, you could listen to onDidDismiss to do something whenever the button was clicked. Here, we'll do that in the handler instead. And in that handler, I want to reset my error. Because we displayed the error to the user, if the user now clicks OK, I want to reset the error and give the user a new chance of, well, entering something valid. So I'll add a function here, clear error, sounds like a fitting name. And in there, I'll just call setError and set this back to null to reset it, or actually an empty string. And then here, the handler will actually point at clear error, not executed here, but just point at it so that it is executed for us when that button is pressed. Again, you can learn more about IONAlert and different ways of configuring it here in this official documentation. Now with that, if we save this and we go back to our application and I click calculate, I get this alert. And this alert here has the Android look. If I would switch to the iPhone preview here and reload this, you would have the iOS look here. But I'll switch back to the Pixel here. Like that. So we have, once I reload, this Android look here, and we get this alert. We can clear this, and we can thereafter, of course, enter something valid, in which case we get no error. But if I enter something invalid, we do get that error. So that now looks way better, and it shows us how we can use Ionic and Ionic components and combine that with React and that extra flavor of TypeScript, which we also have in there. So now let's just finish this up by presenting the body mass index a little bit nicer down there, before we then also add more features and, for example, allow the user to switch between the metric and the non-metric system, so that we allow for different values than just meters and kilogram. So first of all, let's work here on our output, on the result. I will revert this and just accept a number here, so that I can safely call toFixed here and round this number to 2 decimal places here. So by just doing that, this will look a bit nicer because now we can enter something here and we just display the BMI like this. Now in addition, I want to center this. So here I will add a class name of IonTextCenter because you learned that's one of those utility classes that allows us to, well, center the text. In addition, I'll add another h2 tag and therefore actually convert this here to a h3 tag, where I say your body mass index, and also center this, and therefore to center both, I'll just add this class on the surrounding ion card content. And if we do so and we go back, it reloaded automatically. This looks nicer, I think. Now you can, of course, use regular CSS or inline styles to style this even more, but I'll have a separate styling section, so for the moment I'll live with this default style here. Instead now, let's add more components, and let's make sure that we can switch between the different input values and allow not just meters and kilograms, but also size in feet and weight in pounds. It would be nice to have some extra control here at the top where the user can choose whether he or she wants to use kilograms and meters or pounds and feet. If we go back to the official docs, we can scroll through that and you will find a segment button here, an Ion segment button. If you click on Ion segment, you can see the preview. This is how it looks like. And this looks pretty neat. It allows us to choose between multiple values, right? And that's exactly what we need. We need two values here to, well, let the user choose between our different systems. And of course, this exists for both Android and iOS. Now we can see how we use it. We import Ion segment and Ion segment button, and then we just set it up like this here. So let's go to the app component, and I want to add it here in a new row above the inputs. I'll actually add it in a new component. I'll name the component input controls or input control. You can choose any name you want. And there import React from React, of course. Have the input control component here, which is of type React.fc, which stands for functional component. And export it as a default, the input control here. Now let's return some JSX, and the JSX we return here, of course, is this Ion segment. Here, this Ion segment component. Auto import isn't working for me here, so I'll just import Ion segment manually from @Ionic React like this. And between that, now it's working, I got Ion segment buttons. 2 buttons to be precise, because I got 2 values. Now in every button, we can see it's a good idea to have such an Ion label to wrap the text to make sure that the text is presented in the best possible way. So let's import Ion label. And then here we have, let's say, meters kilogram. And on the second button, we got the Ion label with feet and pounds. Now these are our buttons. Now in the app component, we want to add this here inside of a row. We could include the row here in the input control. We can leave it here. I will leave it here. So I'll add an Ion row here and an Ion col. And in there have the input control component we just created. And of course, we need to make sure that we import this newly created component here. So import input control from /components input control like this. Now back in our application, we see the input control here. And of course, we also can get the iOS look if we switch to that. Now this is nice. Certainly doesn't look too shabby. But if you reload, you'll notice that no control is pre-selected. We can change this by going back to the input control. And now there are 2 important steps. First of all, we need to give every segment button a value. Basically a value of your choice, which you'll later be able to extract to find out which button was selected. I'll name this here MKG for meter kilogram, and here FTLBS. Of course, again, these values here are totally up to you. That alone doesn't help us. On the overall Ion segment, we now also have to set value, and we have to set it to the value which should be selected as a default. So for example, MKG. So one of the 2 values you have down there. And I'm using the first value here. If I do that and I reload, now you see that's pre-selected. We can still switch, but this is pre-selected. Now maybe it would be nicer if the default value could be set from outside though, so that we don't hard code this into this component, but we can set it from the place where we use that component. And that can be realized with the help of props, of course. Here we could set this to something dynamic and set this to the selected value, for example. Now here again, we have to tell TypeScript which kind of props we get here, and we'll get a selected value prop, and that will be a string, but actually it will be only one of these two strings which we allow. So this is either mkg or ftlbs. That's also valid TypeScript. We're saying this is not just any string, it's one of these two very specific strings. It's either this string or this string. Only these two values are allowed. That's what we're saying here. With that, we can now use this from outside. We have to set this value from outside now. We can set the selected value here to one of these two values, and you see I get auto-completion here because of my explicit prop type definition. And now again, we get the same behavior as before, but now it's configurable from outside. Now that's nice. We added this control. As a next step, make sure it's not just added, but let's make sure we also can get the currently selected value and use that in our calculation. So we're interested in the kind of value the user selected here in this segment button so that we can correctly use it here in our calculation. Now for that, since this is something which can change dynamically, we need to manage, you guessed it, state. So in the app component, which is where we do our calculation, we add a new piece of state. And this is actually now our selected metric, our selected calculation system, you could say. So I will name this calc units and set calc units. And the type of data we'll store in that state is either a string of mkg or ftlbs. Now initially, I'll set this to mkg. And of course, you could also use our other system here, feet and pounds. And I will use that state snapshot here to initialize my selected value. So this is no longer hard-coded here. Instead, I use my state now. The calc units here. Now I also want to change the state, however, whenever the user selects a new value. So for that, back in the input control component, we can listen to an event on the ion segment, an event which will be triggered whenever the user does choose a new value. With on ion change, we can listen to this change event. How did I know that this exists? Well, the official docs are your friend. There you see this, and you can also read about this here. If you scroll down to events, you see there is an ion change event, which is emitted when the value property has changed, and you listen to this with on ion change, as you see in those examples here. So we know there is this event, and I want to trigger a function which I receive via props if this event occurs. So here I'll add a new key value pair to my props object, and I'll name this prop on select value, but the name is up to you. And the type here is a function which returns nothing but which actually will take a value, and that will be the selected value we got here. So here I will have value which should be, again, this type of data here, mkg or ftlbs. Now we can't bind this here to on select value like this, however, because the problem is that on ion change does not emit this kind of value. And that's what we would need for this to work. If we're saying this function should be triggered when this event occurs, it would mean that this event needs to emit this kind of data, otherwise TypeScript complains. And it does complain here. It does complain because on ion change actually emits an event object which will have a detail property which will have the value the user chose, so one of the values we configured down there, stored inside of it. So we actually need to extract that value from that event object on ion change gives us. So we can do this by adding an extra function in here in the input control component. Input change handler could be a function name we have here. There we get this event object, which is of type custom event. This is a type which is provided by Typescript by default, not just in Ionic apps, but by default in Typescript. And then we can call props on select value and execute this here inside of this function here, and forward event.detail.value. And this is of type any, and we know in our case it will be either this string or this string, because these are the values configured on our segment buttons inside of that segment. And now we connect on ion change here to the input change handler like this. And inside of the input change handler, we now execute the function we receive on this prop, and we forward our detail value, which is one of these two values here. So either mkg or ftlbs. So now this will be emitted on this onSelect value prop. And now in app.tsx, we just have to connect this. So we add the onSelect value prop. And now here, we have to point at a function which expects to get one argument, the value argument, which is either this type or this type of value. So now back in the app component, we can define a new function for that. Select calc unit handler could be a name we choose here. Handler here is optional. I'm using handler here to make it clear that this is triggered upon an event, though to be consistent, I should then also do this here on the BMI and the reset inputs function, which I didn't for historical reasons, how we derived this app, but I will do it here. And there we get this selected value. You can name it however you want here, this parameter. And this will either be mkg or ftlbs, one of these two values, because these are the two values we support in our input control component. And in here, we can then call set calc units, which is this state updating function we got here, to set our state to this new selected value. So here we set the state to the selected value. Now we just have to connect select calc unit handler to our onSelect value here, like this. And now this should be working. And we're now picking up the units the user chooses, and we stored it in our state. We're not using that state for anything right now, but at least we're storing it. Now as a next step, let's also use that selected state in our calculation then. To use the selected units, this new state we're managing, let's first of all update our labels here to reflect the kind of units we're now expecting. So height should be in meters or pounds, and we can output this behind your height maybe. And what we output here should be dynamic. I use my calc units state, and that's either mkg or ftlbs, right? So we can check whether this is mkg, in which case the value I want to output here as text in this label is meters, since this is the input for the height. Otherwise, I'll output feet here. And I'll do something similar here for the weight. I want to output some additional information here based on the calc units. And I'll check if that is mkg. If it is here, I output kilograms. Otherwise, I output lbs for pounds. So now we can already see the result here. If I switch this, you see our labels change, which is good. Gives the user more information about the data that should be entered here. Now, of course, we also have to reflect it in our calculation. This formula here always works for meters and kilograms. Now, if the user enters value in feet and pounds, we have to convert it. For this, down here, I'll add a new weight constant and use my entered weight converted to a number here. However, I want to do more than just convert it like this. I also want to convert it to kilograms, because this formula only works with weight in kilograms. Now, maybe it already is in kilograms, then we don't need to do anything, but maybe it's in pounds, and then we need to convert it. So I'll have my weight conversion factor here, and that is either 1 if the weight was entered in kilograms, or it's something else if it was entered in pounds. Now, if it was entered in pounds, this should be around 2.2. So I'll check my calc units state to see what the user selected and check if that is equal to FT_LBS. If it is, I know that the weight was entered in pounds. So then my conversion factor, let's say, is 2.2. Otherwise, it was entered in kilograms. I need to do no conversion, so it's 1. And now down there, when I calculate the weight with which I want to work, I divide this by my weight conversion factor. And then here I use this converted weight. And I don't need to convert it to a number here anymore because we already did this here. Now the same for the height. I got my height conversion factor here. And for that I check my calc units and check if that's equal to FT_LBS. And if it is, in order to convert feet to meters, my conversion factor here is 3.28 roughly. Otherwise, again, it's 1 because it already was entered in meters then. And then here I got my height, which is the entered height converted to a number divided by the height conversion factor. And then here we use the height. Now we should always calculate the BMI correctly, independent of the measures the user used for entering this. So if I save this and I enter this in meters and kilograms, I get the same result as before. Now if I switch to feet and pounds, I need to adjust this. Now I'm 5.84 feet tall and my weight in pounds is 158.7. So now if I calculate this, I roughly get the same result. Small rounding error because I rounded here too, but that tells us that our calculation works. If I switch this to kilograms, I get something unrealistic, of course, because now that is interpreted as meters and kilograms, but in the pound and feet system, this works. So now we get this included as well, and we're again utilizing a mixture of Ionic with the segment button and so on, and React with Typescript to get there. And this really is a great example of course, a very simple application, but nonetheless an application where we utilize a lot of React Ionic features to build something pretty neat, which we could upload like this to the app stores. Well, speaking of that, we could almost do that, but it's still just a web app, remember? So as a next step, in the next module, we will learn how we can now actually turn this web app into a cross-platform app, which does not just run on the web, but also as a native mobile app, which we can distribute through the app stores.